Hello everyone. Welcome to our class of Python for machine learning. This is a beginner level class. So if you're planning to learn Python for machine learning, then you are in the right place. Because in this class, we will cover everything to get you started with machine learning with Python. Let's take a look what you will learn from this class. Introduction to machine learning with Python, AI versus ML versus deep learning, how does machine learning work, types of machine learning, supervised learning and examples, unsupervised learning and examples, reinforcement learning and examples, examples of AI, deep learning and examples, Jupyter installation, machine learning tutorials and algorithms, demo of iris dataset, linear regression and calculation of R2 or R squared part 2 and part 1, statistics and probability concepts, category of data for machine learning, qualitative data and quantitative data in machine learning, information gain and entropy and confusion matrix, types of event and probability of distribution, how to import databases or data sets in Jupyter, data analysis, train and test data, and logistic regression curve. After completing this class, you will be able to understand machine learning basics, perform linear and logistic regression, use key algorithm, decision tree, SVM, random forest, k-means, naive Bayes, k-nearest neighbor, optimized model with gradient descent, hyperparameter tuning, and regularization. Handle data with dummy variables, one-hot encoding, and k-fault cross-validation. Reduce dimensionality with PCA, save and load models with joblib, and also pickle. This is a project-based class, so during learning, you will have class project. So what you have learned, you will be able to participate in class projects, and you can practice while you are learning. You will have supporting resources in this class, so it will be easier for you to learn. During learning, if you face any issue or if you have any question, then feel free to ask me. I'm always there for you to help you. So let's start learning Python for machine learning together. Before getting into our whole course classes, we have to learn a bit about the introduction to machine learning with Python and what machine learning with Python is. Machine learning with Python involves using the Python programming language to build algorithms that can change, learn from, and make predictions on data. Python is a popular choice for machine learning due to its simplicity, readability, and the vast array of libraries and frameworks available that make implementing machine learning models more accessible. So let's check out the key components of machine learning with Python. Libraries and framework. Python offers several powerful libraries and frameworks for machine learning. Those include Scikit-learn, which is a comprehensive library for traditional machine learning algorithms like regression, classification, clustering, and more. Then we have TensorFlow, which is an open source deep learning framework developed by Google, used for modeling or let's say building neural networks and other complex models. Then we have Keras, a high-level neural networks API written in Python and capable of running on top of TensorFlow. Then we have PyTorch, which is an open source machine learning library developed by Facebook's AI research lab, known for its dynamic computation or computation graph. Then we have data handling, which is efficient data handling, which is crucial in machine learning. Those include Pandas, which is a library providing the data structures and data analysis tools. Then we have NumPy, which is a library for numerical operations and array processing. And the last one we have Matplotlib and Seaborn, which is a library for data visualization. Then move on to machine learning workflows. So data collection, which is used for gathering data from various resources. Data processing or data reprocessing. Cleaning and preparing data for analyzing, which is used for handling missing values, encoding categorical values, and normalizing data, etc. Model selection. Choosing the appropriate machine learning algorithm based on the program, which is used for classification, regression, clustering, and etc. Training the model. Feeding data to the model to learn from it. Evaluation. Assessing the model's performance using metric like accuracy, precision, recall, F1 score, and then etc. Hyperparameter tuning. Optimizing the model's parameter to improve the performance of the machine learning workflow. And then we have deployment, integrating the model into a productive or production environment to make predictions on new data and analyze it based on it. So now you know everything about or some theories which will give you a bit of idea about machine learning or what machine learning with Python is. So without any further ado, let's move on to our first class of Python for machine learning, and make sure not to skip any part of this class because all of the part of the class is going to be very important. And by the end of the classes, make sure to practice all along on your own. In this class, we are going to learn about AI versus ML versus deep learning. Before getting into our practical classes, we have to know more about how Python can be used for machine learning and how many types of machine learning are there and what ideas do we need before getting into our classes. So, here's a brief overview of the differences between artificial intelligence or AI, machine learning, ML, and also deep learning. Let's talk about artificial intelligence or AI. The definition of artificial intelligence is that AI is the broad field of creating machines or software that can perform tasks that typically require human intelligence. These tasks include reasoning, learning, problem solving, understanding natural language, and also perceiving environments. So, what is the scope of AI? AI encompasses a wide range of technologies, including but not limited to machine learning, robotics, natural language processing, and expert system. The examples of AI or artificial intelligences are chatbots, autonomous vehicles, and also recommendation search like systems and also the services. Now let's talk about machine learning or ML. The definition of machine learning is a subset of AI that focuses on the development of algorithms that allow computers to learn from and make predictions or decisions based on data. It involves training models using data to identify patterns and make decisions without being explicitly programmed for specific tasks. Type of learning. 1. Supervised learning, which models are trained on labeled data, and 2 is unsupervised learning. These models identify patterns in unlabeled data. And 3 is reinforcement learning, where models learn by interacting with the environment and receiving the feedbacks. And let's talk about the machine learning examples. Spam email filtering, image recognition, and predictive analytics. 3. Deep learning. The definition of deep learning is a specialized subset of machine learning that uses neural networks with many layers, hence deep, to model complex patterns in data. These networks are particularly powerful for tasks involving large amount of data such as image and also speech recognition. Architecture of deep learning. Deep neural networks, which consist of multiple layers and interconnected neurons or nodes, can automatically learn features and representation from data. The examples of deep learning are voice assistants like Siri or Alexa, face recognition system, and also language translation services. So, what is the summary? AI is the broadest concept, aiming to create intelligent systems. ML or machine learning is a subset of AI that enables system to learn from data. Then deep learning is a further specialized with ML that uses complex neural networks for more advanced learning tasks. So thank you for watching this video up till the very end and hope you understood about everything in this class. If you still have any confusion or any question, feel free to ask me anytime. I'm always there to help you out. Just make sure not to skip any part of these classes. And up to 1 hour of video, we will have couple of theory and also about our ideas classes. Before getting into our practical classes, we will try to give you out the best idea which you need before starting and also installations of Python for machine learning. So we will have couple of theory-based classes which will help you to clear out couple of things before getting into the basics of machine learning with Python. How does machine learning work? So let's get into our class. Learning, or ML, is a branch of artificial intelligence that focuses on building systems that can learn from and make decisions based on data. Unlike traditional programming, where a developer explicitly codes rules and logic, machine learning models automatically identify patterns in data and use those patterns to make predictions or even decisions. Here's a high-level overview of how machine learning works. 1. Data collection. There are two types of data collection. One is raw data, and there are types of data. The process begins with the collecting data amounts of data, or collecting large amount of data, which can come from various sources such as databases, sensors, or online platforms. The types of data is that the data might include numbers, type, or text, images, videos, or any other type of information. The quality and quantity of this data are crucial for building an effective model. 2. Data preparation. Cleaning. Data often contains noise, missing issues, or irrelevant information. Cleaning involves removing or correcting this. So sometimes you can see data is obviously time to time changed, and it is also removed at certain times when other words are seen or termed more, let's say, relevant. So this is how data preparation is done. Normalization or scaling. Data values might need to be scaled to a specific range of improved model performance. So even when you are building yourself a software or even an application. So what it requires is a scaled or a specific range of data that needs to be done or that needs to be created to make an improving model or give the performance which will obviously improve day by day. Splitting data. The data is typically split into two main sets. A training set used to train the models and a test set used to evaluate it. 3. Choosing a model. Algorithms. Depending on the problem in an example like classification, regression, clustering, then different machines learning algorithms are selected. Common algorithms include decision tree, neural network, support vector machines, and also k-nearest neighbor. Supervised versus unsupervised. Supervised learning involves labeled data in example images with label like cats or dogs, where the model learns the relationship between input and also output. Let's talk about unsupervised learning works. With unlabeled data, where the model tries to find underlying pattern or grouping in the data. An example, clustering up. 4. Training the models. Learning process. The model is fed with the training data and it learns by adjusting its internal parameter to minimize errors. This adjustment is often done through optimization techniques like gradient descent. Loss function. The model uses a loss function to measure how far its predictions are from the actual results. The goal is to minimize this specific loss. Evaluation. Testing. Once trained, the model is tested on unseen data. The test set to evaluate how well it generalizes to new data. Metrics. Common evaluation metrics include accuracy, precision, recall, F1 score, or mean squared error, which is known as MSE in short, depending on the problem. Now, there are going to be a couple of terms which are not going to be clear to you, but by classes, I'm going to open up every idea or everything that I've done and also what I understand, which will actually help you to understand it, even though if you are totally a beginner to it. 6. Hyperparameter tuning. Optimization. Sometimes the model's performance can be improved by tweaking hyperparameters, which are settings that control the learning process. In example, learning rates, the number of layers in a neural network. 7 is deployment. Real-world use. Once the model performs well on test data, it's deployed into real world, where it can make predictions on new unseen data. For example, a model might recommend products in an online store, detect spam emails, or recognize speeches. And also a couple of examples, you've seen how couple of image generating tools work or image generating AI works. So basically what it does is that it takes up the real world data too, and also when it is deployed, you can use them and it also upgrades day by day by learning its environment and the users. Continuous learning, such as updating. In many applications, models continue to learn from new data over time to improve accuracy or adapt the changing conditions. So let's check out the summary. Machine learning allows computers to learn from data and make decisions with minimal human intervention. Training. A model involves feeding it data, allowing it to learn patterns and then testing its ability to generalize to new data. Evaluation and optimization are critical steps to ensure the model works effectively in the real world as an application. Machine learning has many applications, including image recognition, natural language processing, recommendation systems, and even more of machine learning there are. So let's get into our class. Machine learning can be broadly categorized into 3 main types, each with its own set of techniques and applications. Here's a brief overview of what type of machine learning are there. First is supervised learning. The definition of a supervised learning is that in supervised learning, the model is trained on a labeled dataset, meaning that each training example is paired with an output label. The objective of a supervised learning or supervised machine learning is that to learn a mapping from inputs to outputs so that the model can predict the output for new unseen inputs. Common algorithm of a supervised learning machine: linear regression, decision trees, support vector machine or SVM, and also neural networks. The applications which are supervised learning are email spam detection, image classification, and also medical diagnosis. Let's check out unsupervised learning. The definition of unsupervised learning deals with unlabeled data. The model tries to learn the underlying structure or distribution inside of the data. The objective is that to identify patterns, groupings, or data structure without explicit labels. Common algorithms of unsupervised learning are k-means clustering, hierarchical clustering, principal component analysis or PCA in short, and also autoencoders. The applications or example of unsupervised learning are market-based analysis, customer segmentation, and anomaly detection. Now let's talk about reinforcement learning. The definition is that the reinforcement learning is an agent learns by interacting with an environment and receiving awards or penalties based on its action. The objective of reinforcement learning is the agent aims to aim or learn a policy that maximizes cumulative rewards over time. The common algorithm of reinforcement learning is Q-learning, deep Q networks or DQN, and proximal policy optimization are known as PPO. The application of reinforcement learning are robotics, game playing like AlphaGo, and autonomous vehicles. Now, there are a couple of things which I've obviously summarized in short, but we're going to go through them, describing them and talking about them in brief. And also, we're going to get into our practical classes from class to class. So make sure not to skip any one. Now, let's talk about the other categories of learning. Semi-supervised learning. It combines a small amount of labeled data with a large amount of unlabeled data to improve learning accuracy. Self-supervised learning. It is a type of unsupervised learning where the model generates labels from the input data itself. Transfer learning. It involves reusing a pre-trained model on a new but related task, which can speed up learning and also improve the performance. These categories cover the fundamental approaches used in machine learning to analyze and make predictions from specific data. And obviously, there are a couple of these web applications and also softwares online which you'll be able to use, and they also learn in different ways. So thank you for watching this video up till the very end, and hope you understood about everything. And just like I said again, is that we're gonna try to describe it to you brief by brief in each classes step by step, because we have classes individual for supervised learning and also unsupervised learning. Also, we're going to learn more about deep learning, and then we're going to show you examples, how they function, which softwares or what type of neural links they use. Supervised learning and also its example. I have prepared a presentation for you guys so that you can understand more and get a clear and so let's get into our class. Supervised learning is a type of machine learning where an algorithm learns from a labeled dataset to make predictions or decisions. In supervised learning, the dataset consists of input-output pairs associated with the corresponding auto output, which is a label. The algorithm's goal is to learn a mapping from inputs to outputs so it can make accurate predictions on new unseen dataset. So, let's talk about the key components. Labeled data. The training data includes inputs and corresponding correct outputs, and these all of them are labels. For example, in a dataset for image classification, the inputs could be images and the outputs could be labels like cats or even dogs. Training phase of supervised learning. The algorithm analyzes the training data and learns patterns or relationships between the inputs and also the outputs. This is typically done by minimizing the differences between the predicted outputs and actual labels. Models. After training, the algorithm creates a model that captures the learned relationships. This model can be used to make predictions on new and also unlabeled data. Prediction. The model uses the learned mapping to predict the output for new inputs. The accuracy of these predictions depends on how well the model has learned during that specific training. Supervised learning is widely used in various applications, from medical diagnosis to stock market predictions, because it provides a straightforward way to model relationships between variable when labeled data is available. Examples of supervised learning. Image classification. The task of image classification is classifying images into specific categories, such as identifying whether an image contains a cat or a dog. The data is that a data set of images labeled as cat or as dog. The application used in facial recognition system, medical image analysis, and autonomous vehicles are also kind of like image classification of supervised learning. Spam detection. The task is classifying emails as spam or not as spam. The data is that a data set of emails labeled as spam or not spam. The application used is such as emails filtering system. Use this to prevent spam from reaching your specific inbox. Then we have is sentiment analysis. The task of sentiment analysis is determining the sentiment of a piece of text, such as whether a product review is positive, negative, or even if it is neutral. The data is that a data set of text with corresponding sentiment labels. The application used in customer feedback analysis, social media monitoring, and also market research are these examples. Then we have is credit scoring. The task of credit scoring is predicting whether a person will default on a loan based on financial history and also other factors. The data or a data set of borrowers with labeled incomes, in example, default or if it is paid. The application used by financial institution to access the risk or assess the risk of lending the money is used or is also an example of supervised learning. Speech recognition. The task is converting spoken languages into text. Well, in data, a data set of audio recordings paired with corresponding transcripts. The application used for speech recognition is virtual assistants like Siri and Alexa use this to understand their own commands. In all these examples, the key is the availability of labeled data, which is used to train the model to recognize patterns and make accurate predictions on new unlabeled data. So hope you understood about everything in this class. In our previous class, we've talked about supervised learning and hope you understood about everything in this class. So in this class, I'm going to give you more ideas about unsupervised learning and its examples. So let's get into our unsupervised learning is a type of machine learning where the model is trained on data without explicit labels or annotations. The goal is to discover patterns, structures, or relationships like within the data. Unlike unsupervised learning, where the model learns from labeled example, input-output pairs, unsupervised learning focuses on finding hidden structures in the input data itself. Let's see what the key components of unsupervised learning are. Clustering. The process of grouping similar data points together based on certain features. Common algorithms include k-means, hierarchical, or hierarchical clustering, and also DBSCAN. Now, let's talk about dimensionality reduction. Techniques like principal component analysis and TSNE are used to reduce the in the data while preserving important structures, making it easier to visualize or process. Now, you guys might think of what is DBSCAN or what is also principal component analysis. So basically, DBSCAN or density-based spatial clustering of application with noise is a clustering algorithm which is used in machine learning to partition data into clusters based on their distance to other points. It's effective at identifying and removing noise in a data set, making it useful for data cleaning and also outlier detection. Now, what is PCA, or Principal Component Analysis, is a powerful technique used in data analysis, particularly for reducing the dimensionality of datasets with preserving crucial information. It does this by transforming the original variables into a set of new, uncorrelated variables called principal components. Anomaly detection or anomaly detection. Identifying data points that differ significantly from the majority, which can be useful for detecting outliers, fraud, or even unusual events. Association rule learning. Finding interesting relationships between variables in large datasets. A well-known example is the a priori algorithm, which is used in market basket analysis to identify items frequently bought together. Unsupervised learning is valuable when labeled data is scarce, or when exploring the underlying structure of data for further insights. So here are some examples of unsupervised learning applications along with brief explanation. 1. Customer segmentation. Example. A retail company uses clustering algorithms like K-means to group customers based on purchasing behavior. The purpose is to identify distinct customer segments for targeted marketing and also personalized offers. Anomaly detection in fraud detection. Example is that banks use unsupervised learning to detect unusual patterns in transaction data that might indicate fraudulent activity. The purpose is to identify outliers, transactions that deviate significantly from normal behavior, flagging them for further investigation. Document clustering. The example are news articles are grouped into clusters based on their content using algorithms like hierarchical clustering or latent directed or directlet allocation or LDA in short. So what is LDA? So now let's learn a bit more about LDA. Latent directlet allocation, or LDA for short, is an unsupervised machine learning algorithm. Similar to the clustering algorithm K-means, LDA will attempt to group words and documents into predefined number of clusters. An example, topics. These topics can be used to organize and also search through documents. While LDA consists of two parts, the word within a document, which is a known factor, and the probability of words belonging to a topic, which is what needs to be calculated. The algorithm tries to determine for a given specific document how many words belong to a specific topic, and then it's going to create or organize itself an own topic. The purpose of document clustering is automatically organize large collections of data, making it easier to find related articles or even topics. Image compression. Example of image compression are techniques like principal component analysis or PCA, which reduce the number of pixels in images while preserving important features. The purpose is to compress images for shortage of transmission, maintaining high quality while reducing the specific file size. Genomic data analysis. The example is researchers use unsupervised learning to group genes with similar expression patterns, identifying potential biological functions, or even disease markers. The purpose is to discover hidden patterns in genetic data that could lead to new insight in biology and also medicine. Market basket analysis. The example is that retailers analyze transaction data to find products frequently purchased together using the a priori algorithm. You can see sometimes in couple of, let's say, web applications such as Alibaba or maybe even Amazon. Sometimes you check out a product and you have this other recommendation section where it shows almost or frequently bought with. So this specific algorithm is used for market basket analysis. The purpose is to optimize product placement and also cross-selling strategies by understanding consumer purchasing habits. These examples demonstrate how unsupervised learning can uncover hidden patterns and insights in various fields, even without labeled data. In our previous classes, we've covered up and also tried to give you the best idea and clear idea about supervised learning and also unsupervised learning. In this class, we're going to learn about reinforcement learning and also its examples. I have created another presentation for you guys so that you can get the clear and vivid idea about it, and also you can know more. So, reinforcement learning, or RL, where an agent learns to make decisions by taking actions in an environment to maximize cumulative rewards. Unlike supervised learning, where the model is trained on dataset with labeled examples, reinforcement learning involves learning from the consequence of actions in a dynamic system. Let's check out the key components. Agent, the decision maker, or even the learner. Environment, the external system with which the agent interacts, such as user or even the software. State, a representation of the current situation of the environment. Action, the choices available to the agent. And the reward is a feedback signal from the environment indicating the immediate benefit of a specific action. Policy, a strategy used by the agent to determine the next action based on the current state, such as feedbacks and also getting support from that feedback. Value function, a function that estimates the long-term return or sum of future rewards of state or state action pairs. Q-learning, a popular RL algorithm where the agent learns a Q value representing the expected utility of an action in a given state. Now, up till now, we've been talking about Q learning or even the Q value. So what are these? Well, the Q value is an analog of the P value that incorporates multiple testing correction. The Q value is defined as the minimum false discovery rate at which an observer score is deemed significant. The Q value attempts to control the percentage of false positives among a collection of scores, such as determining or giving credits to the person who is most active on a specific site. So, what is the learning process? The agent interacts with the environment by taking actions and receiving feedbacks in the form of rewards. Over time, the agent learns which action yields the highest rewards and adjusts its policy to maximize the cumulative rewards. Techniques like exploration, trying new action, and exploitation, choosing the best known action, are balanced to ensure the agent learns effectively. Reinforcement learning is used in various applications, including robotics, game playing, autonomous vehicles, and more complex decision-making tasks. Reinforcement learning, or RL in short, has been applied across various domains, demonstrating its versatility and power in solving complex problems. Here are some notable examples. 1 is game playing. First off is AlphaGo. It is developed by DeepMind. AlphaGo is an AI that mastered the game of Go, a complex board game with more possible moves than atoms in the universe. AlphaGo used reinforcement learning to learn from millions of games played by humans and itself, ultimately defeating the top players, human players. Dota 2 AI, which is OpenAI 5. OpenAI developed by RL-based AI that played the multiplayer online battle arena game Dota 2. The AI learned strategies by playing millions of matches, eventually defeating professional human teams. Robotics. Robotic manipulation. RL is used to train robots to perform tasks like picking up objects, assembling parts, or even folding laundry. For example, a robot hand developed by OpenAI was trained using RL to solve a specific Rubik's Cube. Autonomous drones. RL is used in training drones to navigate complex environments, avoid obstacles, and perform tasks like delivery package or aerial photography. 3. Autonomous vehicles. Self-driving cars. Companies like Waymo or Tesla use RL to improve the decision-making algorithms of their autonomous vehicles. RL helps these vehicles learn to navigate roads, handle complex traffic situations, and also make real-time adjustments. 4. Finance. Algorithmic trading. RL is applied in trading strategies where the agent learns to buy or sell stocks based on market conditions to maximize the profit. The agent continuously adapts its strategy based on market fluctuations. Portfolio management. RL algorithms are used to optimize portfolios allocation, adjusting investment in response to market changes to maximize return over time. 5 is healthcare. Personalized treatment. RL is used to tailor treatment plan for patients by learning from their responses to different treatments. For example, in managing chronic conditions like diabetes, RL can optimize medication dosage over time. Drug discovery. RL helps in identifying potential drug candidates by effectively or efficiently exploring the vast chemical space to find molecules with desirable properties. 6, which is recommendation system. Content recommendation platforms like YouTube, Netflix, and Spotify use RL to recommend videos, movies, or music to the users. The system learns from user interaction to continuously improve the relevance of the recommendations. E-commerce personalization. RL is used in online shopping to personalize product recommendations, optimization or optimizing for user satisfaction, and sales conversions. 7 is natural language processing or NLP, chatbots, and conversational AI. RL is used to train chatbots to handle conversations more effectively by learning from past interactions. The AI improves its ability to understand and respond to user queries over time. Machine translation. RL can be applied to improve the accuracy of machine translation system by optimizing the translation process based on feedback from human user or automated metrics. These examples highlight how RL can be adapted to a wide range of challenges, from mastering complex games to making critical decisions in real-world application. So thank you for watching this video up till the very end, and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class. In our previous classes, we've covered everything such as supervised learning, unsupervised learning, and also reinforcement learning. In this class, we're going to learn about the examples. So here are few examples of AI system and a brief description of each. First one is ChatGPT. It is an advanced controversial or conversational AI developed by OpenAI, capable of understanding and generating human-like text based on the input it receives. It's used for customer support, content creation, and also personal assistance, which is also one of the most used AI in this age. Siri is an Apple's voice-activated assistant that helps users perform tasks like setting reminders, sending messages, and searching the web using natural language processing and also speech recognition. Not only these, you'll be able to command it to also like do a couple of things, maybe like open certain application and also post certain things. All of them is done by Siri. Google Assistant. Google's virtual assistant that offers similar functionalities to Siri, but integrates deeply with Google's ecosystem, helping with tasks like navigation, information searches, and also controlling smart home devices, and also all the things what Siri can do. IBM Watson. It is known for its powerful data analysis and natural language processing capabilities. Watson is used in various industries for tasks like medical diagnosis, financial forecasting, and also customer service. Tesla Autopilot. It is an advanced driver assistance system in Tesla vehicles that uses AI to perform tasks such as lane keeping, adaptive cruise control, and parking, aiming to enhance driving safety and also its convenience. And obviously by now it is already running and also it's quite safe, I would say. DeepMind's AlphaGo, an AI developed by DeepMind that famously defeated professional human players in the complex board game Go, demonstrating advanced strategic thinking and learning capabilities. Amazon Alexa, which is Amazon's virtual assistant embedded in Echo devices, designed for voice interaction to control smart home devices, play music, provide weather updates, and also answer questions. DALL-E. It is a model developed by OpenAI that generates images from textual descriptions, showcasing the ability to create visual content based on written inputs. Each of these examples highlights a different aspects of AI. from conversational agents and virtual assistants to advanced machine learning models and autonomous systems. So, hope you understood about everything in this class. If you still have any confusion or any question, feel free to ask me anytime. I'm always there to help you out. So, without any further ado, let's move on to our last theoretical class of Python for machine learning. Welcome to our last class, our last theoretical class of Python for machine learning. After this class, we will start our practical classes installation to get you started with everything. We're going to learn about deep learning and also its examples. Deep learning is a subset of machine learning, which is itself a subset of artificial intelligence. It focuses on algorithms inspired by the structure and functions of the brain called artificial neural networks. Here's a brief overview. Key components. 1. Neural networks. The core of deep learning models composed of layers and nodes, which are neurons. Each node mimics a neuron in the human brain and performs a simple computation. Layers are typically categorized as input, hidden, and also output layers. 2. Layers. 1 is input layer, which receives the initial data. In the hidden layer, it's intermediate layers where data transformation occurs. Deep learning models often have many hidden layers, leading to the term deep learning. And in the output layer, it produces the final output of that specific model. Training. The process of teaching the neural network using a dataset. It involves adjusting the weight of the connections between neurons to minimize the error in predictions, typically through a method called backpropagation, combined with an optimization algorithm like gradient descent. Activation functions. Functions apply to the output of each neuron to introduce non-literality or non-linearity, which enables the network to learn complex patterns, where common activation functions include ReLU, or reluctified linear unit, sigmoid, and also tan. So what is ReLU or linear unit? Of artificial neural networks, the rectifier or ReLU activation function is an activation function defined as the positive parts of its argument, where is the input to a neuron. This is also known as a ramp function and is analogous to half-wave rectification in electrical engineering. It is basically used to introduce non-linearity in a neural network, helping mitigate the vanishing gradient problem during machine learning models and also enabling neural network relationship in a spec is basically kind of the same. And also loss function, which is a function that measures how well the neural networks produce actual results. The goal of training is to minimize this specific loss. Now let's check out the applications. Image and video recognition. Identifying objects, people, or activities in images and videos, an example, facial recognition. Natural language processing or NLP. Understanding and generating human language, an example, language translation application, sentiment analysis, and all. Speech recognition. Converting spoken language into text. Autonomous vehicles. Enabling self-driving cars to perceive and navigate their environments. Healthcare. Assisting in diagnosis diseases from medical images and predicting patient outcomes. Let's check out the popular frameworks. TensorFlow. It is developed by Google, widely used for various deep learning applications. Then we have is PyTorch. It is developed by Facebook, known for its ease and use of dynamic computation graph. Keras, which is a high-level neural networks API running on top of TensorFlow. Deep learning has significantly advanced the field of AI, leading to breakthroughs in various domains due to its ability to automatically learn features from raw data, outperforming traditional machine learning techniques in many tasks. Now, let's check out the examples of deep learning. 1. Which is image recognition. Example is identifying objects in images using convolution or convolutional neural networks, or which is known as CNNs in short. Applications for image recognition is used in social media platforms for tagging photos and medical imaging for detecting diseases, and in autonomous vehicles for recognizing road signs and also pedestrians. Speech recognition. Example: converting spoken language into text using recurrent neural networks, or RNNs in short, and more advanced model like transformer networks. Applications for speech recognition is used in virtual assistants like Siri, Alexa, and Google Assistant to understand and respond to voice commands. Natural language processing, or NLP. Example: machine translation using models like Google Translate, which often uses transformer-based architectures like BERT or GPT. Application for NLP is used in language translation services, chatbots, and sentiment analysis of text data. Generative models. Example of generative models are generative adversaries or adversaries, networks or GANs for creating realistic images, videos, or even music. Application, which is used in creating art, designing virtual environments in video games, and generating deepfakes. Recommendation systems. Example: personalized content recommendation using deep learning models that analyze user behavior and preferences. Application for recommendation systems are used by streaming services like Netflix and Spotify, e-commerce platforms like Amazon, and social media platforms like YouTube and Facebook. Healthcare. Example of healthcare is diagnosing diseases from medical images. The usage is deep learning models are used to detect diseases like cancer from MRI scans or X-rays, improving diagnostic accuracy. Fraud detection. Example is that identifying fraudulent transactions. Where is its usage? Banks and financial institutions use deepfake learning models to detect unusual patterns and flag potential fraudulent activities. Game playing. Example: mastering complex games. Usage: DeepMind's AlphaGo, which uses deep learning to play the game of Go at a superhuman level, defeating top human players. Art and creativity. The example of art and creativity is generating artwork and also music. Where is the usage? Tools like DeepArt and AIVA use deep learning to create original artwork and also music composition. Customer service. Example, chatbots. Usage is companies deploy deep learning powered chatbots to handle customer inquiries and also support, improving response times and customer satisfaction. These examples illustrate the broad and transformative impact of deep learning across various fields, showcasing its potential to solve complex problems and create innovative solutions. So, hope you understood everything up till now or up till this class on all of these theories and these ideas. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. And from our next class, we will start our practical classes and we will also start our installation processes. So make sure not to skip any part because if you do, you might miss out on something very important and then it will be a hassle later on. So without any further ado, let's move on to our next class. In our previous classes, I've tried giving you the ideas to clear out a vivid idea about how machine learning works and what are the components and how many types of examples of machine learning, AI, and deep learning are there. Now, from this class, we are starting our practical classes. So before getting into more practical, we have to learn how you can use Jupyter and how you are going to install it on your device. So, without any further ado, let's move into our class, but make sure that you do not skip any step because if you do, you might miss out on something very important. And whatever web browser you have on your device, I would suggest you open that up. It could be Google Chrome, Mozilla Firefox, Microsoft Edge, it doesn't matter. You just need a stable internet connection, that's all. So, let's move on to our class. As you can see on my screen, I have opened up Google Chrome. Now, the first thing which I would suggest is download Jupyter, but you will be able to use it on your console. But if you're a totally beginner, I have prepared something for you which you'll be able to understand and which is a lot more beginner friendly. Okay, so first thing, what I would suggest you to do is download in Anaconda. So I'm going to do is type in Anaconda. And you're gonna do is just download an Anaconda Navigator, and you'll basically find it on their own official browser, or their own official site, which is Anaconda Navigator or docs.anaconda.com. You can also see download Anaconda Distributor, but you're going to select on Anaconda Navigator. And obviously, if you have yourself, let's say, any type of antivirus or online antivirus, it will already show you that this is totally a trusted site. Now from here, what you're going to basically do is that you see this option over here at the top. You don't even have to like log in or sign up or anything. Just click on download Anaconda and it will just redirect you to another site from where you're just going to put in your email address and then you're going to just submit it. So I'm going to put in my email address. And after you're done, just click on submit. You can also skip the registration. It's basically up to you. You can see it has been successful. Then basically what you're going to do is that you're going to open up your Gmail account. So let's just go off the Gmail. So you can also open it up from here. So I'm going to, and basically when I will check out my inbox, it will already be there on the first one. So I'm going to just refresh it. Now you can see it over here. So I'm going to click on that and you're just going to press on download. You don't have to worry about any other stuff. And then you'll basically see that it will start downloading. You can see this option over. I'm going to click download and there you go. It will start. And the rest of the stuff you're inside of that, let's say Anaconda Navigator. Now there are a couple of things which you basically need to know about Jupyter. So Jupyter is widely used for several reasons, primarily in the field of data science, machine learning, and also scientific researches. Well, in this class, I'm also going to clear up a couple of ideas about Jupyter and how these actually work. And you'll also be able to download, Conda installation. Okay, so basically this is how you're going to download the navigator. So I'm going to just cut this off, and if it doesn't, just go back. And if you want to download the installation file, you'll also be able to do that just by going through anaconda.org. So what you're going to basically do is download Conda installer. You'll be able to download like that too. You can see installing Conda 2 like 24.7. You'll also be able to use that, but I would suggest you just try downloading the Anaconda Navigator first. And if it feels more like, complex and more, let's say, hard for you, then you can move on, try out the Conda installer. You'll be able to use that just the way I'm doing this one too. Just make sure that you are connected to the internet most of the time, and we're going to wait until our Conda installer has been downloaded. Then you're going to install it up on your device, and then you're going to run it up. And then basically you're going to find out a lot of, tools which you'll be able to use, not just, Jupyter. There's also going to be Python. Okay. So basically there's going to be a lot of stuff. But one thing you have to keep in mind that it is also using Python as the base. Okay. And it also has the name of its user, and that is why it's called Jupyter. So Jupyter. Okay. One of the most important thing about using Jupyter is that about its interactive computing. Jupyter allows user to interactively write and execute codes, making it easier to test, debug, and also iterate over code quickly. Now, you will be able to create yourself up an instance on your browser, or let's say even on your PC. But when you're using Anaconda, or when you're using any of these softwares to actually get the help and then making your own instance, just like running Jupyter Notebook, well, it's just a bit more optimized, and that is how its service is actually, or its service actually functions. So let's just wait for a bit, and after our installation file has been downloaded, I'm going to install it on my device and show you how you are going to follow up the steps. After downloaded on your device, you'll basically see this over here. Just click on it. We're going to open it up so that it just, runs on my device. Just wait up a bit. Now you can see that this setup has opened up. So what we're going to do is going to be removing this and click on next. Agree to everything. I agree. Recommend. You can use all users if you want to, but I'm just going to create shortcut. And you can also add Anaconda tree to path environment variable, but I would just Anaconda as use that. But if I don't want to, I'm just going to keep it just the way it is. So I'm going to click on install, and it will just install it on its own. You can see it from my screen. So after this has been installed, you can see this is also kind of the same. I'm just going to close it up. And this will just set up the package caches right now. And then we're going to open it up on our device and check out the interface. So the next important thing about using Jupyter is because of its rich text support. Jupyter Notebook supports Markdown, allowing user to create rich text alongside their code. This makes it easier to document the processes, including explanations, and also present results in a readable format. And also visualization is also very important nowadays, because obviously people don't like to read more, but they want to visualize more. So Jupyter integrates well with many data visualization libraries, such as Matplotlibs, Cbarn, Plotly, on etc., which makes it straightforward to create and display visualizations in line. So you can actually come to conclusion that this one, our Jupyter Notebook, is a lot more, let's say, used. I wouldn't say that useful, but it is also useful, but it is more used in this age, comparatively to the other softwares which you will find online, such as this Anaconda Navigator. Because a lot of people also use CMD, or maybe they also use it inside of Python. Okay, but when you use Jupyter, it's going to be a lot more, let's say, beginner friendly. And when I actually give you out more clear idea about the interface, you will actually be able to go through them and check it out on your own. So let's just wait until our installation file has been done. You can see the installation has been done. I'm going to press on next, next, and we're just going to just launch it on our device right now. You can see it will just start, just open it up. So this is how it's going to look like after you have installed it. So obviously you're going to sign in, but this is how the interface will actually look like. You can see there are a couple of these applications which you'll be able to use from PyCharm, Anaconda AI Navigator, Cloud Notebook, and there's going to be a lot more after you log in. So first thing I'm going to do is going to be connecting to whichever cloud you want to use, maybe like anaconda.org or Anaconda Cloud. You can use anaconda.org if you want to. So first thing, what you're going to do is go off the file and you can restart it up if you want to. So let's just go off to Anaconda Cloud and sign up. You can also do the anaconda.org. So after you click on that, you will basically be redirected to another website. From there, you're going to create yourself an account. Maybe I'm going to create myself a new account, which will actually help you to understand how you're going to create that account. So let's say I'm going to start off with my email, which I'm going to put in right now, and I'm going to put in my password. And as I've put in my password and also my email, you can see the provided credentials are invalid. So I'm going to just check it out a bit more at gmail.com. So I'm going to sign up instead of signing in. My bad. So here I'm going to put in my name over here and I've signed up. Now you can just create whatever password you want in case. I'm just going to put in QWERTY just in case. Sign up. And it's going to create the account for me. I'm going to save it up just in case, and I will have the verification code on my email account. And I'm going to put in my code, which is going to be this one. And I'm going to continue. And after your account has been verified, you're just going to log inside of the Anaconda Navigator too. Okay, so there we go. It's just going to create ourselves an account, and basically you're good to go. And you can also connect it directly from the Anaconda Navigator at the same time. And you can see there's an update, and there's going to be a couple of updates, which you'll basically see. So I'm going to click on yes. What I'm going to do is going to be dismiss. I'm going to close it off. Now, there are these tools or these applications which you'll be able to work with. You can see most of them are PowerShell and all, but we're going to basically need our Jupyter Lab or the Jupyter Notebook, which is one of the most important thing of this class. So first thing what we're going to do is that after we connect it to the cloud, you'll already be able to create an instance. So when you click on this launch on Jupyter, it's obviously going to create an instance for you on the web. Basically, it's going to be an environment, or let's say, yeah, it's kind of like a private server, which you'll be able to work with. So you can see launching the notebook. So it's going to launch the notebook. Let's say we're going to create one in Google Chrome. So I'm going to click on just once. And there we go. This page is going to be your Jupyter notebook. And we're going to obviously brief out and describe a lot more things which you will find out inside of the interface. So the first thing which you can see over here that this is the Jupyter interface. And this one, or this, like whatever we could say, a header. But this is also kind of like a button which will obviously redirect us anytime when we open up any folder and we just click on Jupyter. It's just going to get us back inside of the home page. Okay. So now another important thing about Jupyter, or the key feature about Jupyter, is that about its language support. While originally designed for Python, Jupyter supports many programming languages through its kernel system, including R, Julia, and also Scala. So JU or Jupyter or JU is basically called Julia. So it's basically the mixture of Julia, Python, and then a bit more. Okay. And about its reproducibility is that notebooks can be shared easily, allowing others to reproduce the results by running the same code. This is crucial in research for verifying results and in data science for collaboration. Jupyter also integrates well with variety of data analysis tools, libraries, and also frameworks. Okay? And it is also very important for statistical modeling and also machine learning. It even has a large active community and a rich ecosystem of extensions and tools which continuously enhances its capabilities and also usability. So I'm going to obviously show you out all of the things and everything which you can see over here on the interface of Jupyter. Starting with the main interface is basically a notebook dashboard. So you can see there is a file browser, basically this one. So I'm just going to go back. Let's say I'm going to go back just a bit more. So I'm going to go off the file. Let's just go back on home. Okay. So it's going to be a lot more easier for you to understand from here. So basically, this is the notebook dashboard. It shows all the files and all directories inside the current directory. Okay, so all of these are the current directory, which we have over here inside of our folder. And over here on the running is the lists of all the currently running notebooks, terminals, and also other sessions. Well, if you have the full version, well, you're also going to see clusters, which is not available right now, but you'll obviously be able to use clusters if you if you've used Anaconda or Jupyter, recently. Okay. So it clusters up, used up managing parallel computing clusters. So as we don't have it right now because we just opened up Jupyter right now. Okay. So inside of the notebook interface, we have the title, the name of the notebook, which can be changed by clicking on it. So let's say this one, I'll be able to select this, and I'll also be able to rename it anytime I want to. Okay, I'll also be able to delete it anytime I want. So let's just go back into our directory of our files. You'll also be able to create new files. It could be Python, Markdown file, text file, terminal, CSV, notebook, console, whichever one you prefer. You can also open it up from Path. You can download it up, save them, log out, shut down, whatever you prefer. Okay. So we also have the menu bar over here. The menu bar contains drop-down menus for various operations. So basically like this. Okay. So this is basically called the menu bar. There's file, edit, view, then settings, and also help. And if you have the full version, you're also going to get insert, cell, kernel, widget, and also help. So file basically is, it's kind of like the operation related to notebook files, such as new, open, save, etc. Inside of your edits, you'll find out editing commands like cut, copy, paste, cell, etc. But as we don't have it right now, is because we're not using the full version. But if you're using the full version, you'll basically get all of those. Okay. You can also see enable extension manager over here. Inside of your viewing menu, you'll find out toggling the visibility of elements such as toolbars, then, the line numbers, etc. Inside of your insert menu, you'll find out inserting cells above or below. In your cells, you're going to find out running, stopping, and converting cells. Inside your kernel, you'll find out interacting with computation kernel, restart, interruption, etc. Inside of your widget, you're going to find out for managing interactive widgets. And inside of your help, you're going to find out links to documentation and also help resources. Okay, so these are the things which you'll find out inside of, Jupyter interface. So about the features and also functionalities, it's about its interactive and execution. Inline code execution runs code cells individually and see the output immediately below the cell. But as we do not have anything, we cannot run any specific thing. But just in case, maybe this one. If I run this on inside of the Jupyter notebook, it's going to just, it's going to run in the JSON file. But even though if we have it, will not be able to customize it right now. Okay, it's because it already has the inline code like execution done. We need kernel support, which is a multiple language which are supported via different kernels, such as IPython for Python, IR kernel for R, or maybe etc. So you can see this is a JSON file, so we'll not be able to, do anything about it. But maybe like JPG, we have this, but it's just going to open up the folder, or it's just going to open up the data which we have. But you will not be able to, customize it anytime soon. So there we go. We have open, we have download, we have rename, duplicate, delete, all of them over here to actually manage our data. And then we also have new over here, which will allow us to create a new file or a new document. And we can also upload files from our device inside of this server to actually test it out before deployment. And another thing is that you will also be able to directly drag any file inside of these folders over here. Now, we've talked about visualization, why it is very important and why people use Jupyter. First is the most important thing is about its inline plots. It is used to generate and display plots and graphs directly within the notebook using libraries like Matplotlib, Seaborn, then Plotly, etc. So when we go off the files or when we go off to our direct folder, you can see you'll be able to see all of these folders. You'll be able to upload them. You'll be able to also import them anytime you want to. Then we have is interactive widgets. So we did not go to that class yet, but when you want to use extensions to actually increase the functionality of Jupyter, you'll be able to use widgets. So you can use IPython widget to add interactive controls like slider, buttons, and also text boxes to your notebook. Then comes about data handling. First off comes Panda integration or Pandas integration, which is used to handle and display data frames easily. And about file operation, you can read from and write to various files formats directly from the notebook. So there are also a couple of a lot of important things about Jupyter, but we're going to go through them step by step. Now, about one of the most important thing is about writing or running a code, and also about documentation. While writing or running a code, write code in code cells and execute with Shift plus Enter, and view outputs directly below the cell. While documentation, add markdown cells for explanation, documentation, and instruction. So basically what you want to do is click on new, and just in case maybe I want to create a notebook. So inside of this notebook, we're going to, let's say, use maybe Python IP. So I'm going to use Python 3 and I'm going to click on select, and inside you're going to run in your code. Maybe you can use prints just like this, and you can use other command cells. But from here, you can see we have all of these settings, just like I said, such as file, edit, view, run, kernel, settings, and help. You're going to confirm your age, data collection, enabled, and then press on continue. And you can get started. So this is also kind of like an AI, which will basically help you to start chat with notebook context. You'll be able to get started using this AI, which is an assistant, and you're going to write your codes over here. So now you know everything about setting up Jupyter and how you can use Jupyter and how you can use different kernels. And you can also change them anytime you want. Maybe use kernels from preferred sessions, maybe use different ones. You can see there's no kernel, but you'll be able to basically use them, get them over here inside of Jupyter Lab, and you'll be able to work with it. And if you want to increase your functionality inside of Jupyter, you will obviously be able to use extensions, download them up, and use different languages in cases. So thank you for watching this video up till the very end, and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of Python for machine learning. In our previous class, I've shown you how you can install Anaconda Navigator and also work with an instance on Jupyter Notebook. In this class, I'm going to show you about the machine learning tutorial and also a couple of algorithms which you can run on Jupyter Notebook. And also, I'm also going to show you and addition to this class of how you are going to use other languages on Jupyter Notebook too. So without any further ado, let's open up Anaconda Navigator and let's also open up a web browser on our device. As you can see on my screen, I have opened up Anaconda Navigator. We're just going to launch our Jupyter Notebook, which is going to create ourselves an instance. In my previous class, I've already shown you how you can launch it up and also use it on Google Chrome. So you're going to click it on again, and you're going to wait until you have the prompt on your screen where it's going to show you what do you want to use to open up Jupyter Notebook. So after launching it up, you can basically see the host or the local host will open up. You can see this is the server, and you'll also be able to use a password or a token because of your privacy. But as I have it on my own instance, you can see this is how it will look like, and I would not require any password or token. But if I do want to create myself of the server, which is going to be a bit more private, you'll be able to create yourself a token or a password so that you can get inside or get the access. Now, before starting our machine learning tutorial, first off, what I want to show you is that you can see when you click on new over here, you will be able to start a notebook, but from there, you will only be able to use Python 3. So you can see Python 3 is already selected, and you can see there are no other, kernels or no other languages. So for that, what you can basically do is go off to new code or let's say the new tab of your, any web browser, and you can search or download code, let's say code mirror. Now, what the code mirror, what it basically does is that it helps you to actually authenticate and also run another codes inside of Python or other IDEs. This is kind of like, let's say, an extension. You can use it as an extension, okay? But it only works with Java, okay? As it only works with Java, but you will also be able to use other ones because this is kind of like an extension, okay? Even though it is based on Java, what it does is that it encodes other languages inside of it too. So what you're going to basically do is go on to their own site, which is codemirror.net. You can see it over here. Now you can see extensible code editor. So from here, you'll be able to download it or use this extension inside of your own IDE. But as I'm only using Jupyter right now, let me show you how you are going to use machine learning. So first thing, what I want to show you is that I'm going to create up myself this new file. So here, I'm going to name this file to be, let's say, Python. Okay, this is what it's going to be the name. And the extension you can see, which is IPYNB, which is IPython. So if I rename it, you can see it has been like made 1 minute ago. Now, if I go back home, and you'll basically see that it is going to be on our home. So let me just cut this off. If I go home and if I just keep on going down, you'll basically see we have this Python file over here. And this is termed as a script or just as a notebook. So even if you open up your directory, so if I go off to my files and if I go off to my PC, COS, and you'll basically see that on our folder or the directory where we have is this directory, Jupyter server root. So I can go off to that specific file over here. And then what I can do is that I can open this file directly from my folders. So basically, if you want to find out the folder inside of your PC, what you basically have to do is go off to your PC, then select up the drive, and then go off to the user and select the username which you are logged in on. So basically, this is the path. Now, from this path, if I just keep on going down, you can basically see, there we go. We have this file over here, which is Python IW, or which is also IPYNB. Well, this is basically the file which I've created right now. And if I just go back onto my browser and I can open it up from here, I can also open it up directly from here. So if I just try to open it up from here, you'll basically see this is how it's going to look like because there we go. We have basically nothing. Okay, so I'm using VSC over here, but we have nothing over here. So what I'm going to do is that I'm going to open up that Python file over here, and we're going to give couple of data inside of our Jupyter notebook. So let's say I'm going to put in maybe a name. Name is going to be equal to a specific data. So if I put in equal, and you have to put in double quotation because we are using Python. So I'm going to put in double quotation. I'm going to put in orange, double quotation, hit on enter, and then I'm going to put in numbers equal. Numbers is going to be, let's say, 600. So that is basically it. I'm going to hit press on shift and enter to run the code or run the command. You can also run it from here or even run it from here, whichever you feel comfortable. Now, if I want to actually print out this specific data with the Python code, I can also do that. So first I'm going to zoom in just a bit so that it is also easier for you to check. So I'm going to put in the commands of Python, such as print, open up the parentheses, and now if I put in name, is going to be obviously orange. So I'm going to put in plus, and then I'm going to put in this one quotation, not double quotation, only one quotation. So if I put in has in the beginning, because let's say orange has this specific, okay, but I can put in also something is name, orange value is, now put in one quotation at the ends and put in plus again. So after I put in the plus, I'm going to use the numbers or the value which I have as a string, because we can only use numbers as a string. So if I put in str and then open up the bracket again, and here I'm going to put in numbers. Okay, now it has already detected it up. Now after that, I'm going to close it off. Orange value is 600, and that's all I need. So okay, now what I'm going to do is you can either close up the parentheses, and you can also keep it just the way it is right now. But now if I hit on shift and enter, you can see that we get that command, or we get that such as orange value is 600. Now you can already see that it will already be saved as an autosave because we are using it on our instance. So if I basically save this up, or even if I go off the VSC, you can see it has been printed right over here. But we do not get the answer over here because now we are using Jupyter. So if I basically just run another one, let's say maybe I want to rerun this again, hit on shift and enter, and you can see the number has also changed, but we are still getting the same value. So if I go off the VSC right now, you can still see this is not working, or there is no specific value. But what we have to do is that we have to refresh up the whole thing so that we can run it on our instance, and also it will be saved on our file in our directory. Okay, so what we have to do is we can rerun this over and over again, and every time you rerun any instance or any of these command line, you'll basically see that these numbers will change. So if I rerun this again, so as a shortcut key, you can use shift and enter to rerun. You can see there is 8, and now this is 16. But obviously this was 1, and this is 2, right? So you'll be able to work up like this whenever you want to. So basically now you know how to run the Python codes. Now let's try to get into a bit more of our algorithm. So first thing I'm going to do is that we're going to save all. There we go. It has been saved. So I'm going to go back home. There we go. So I'm going to refresh it up back again so that we have all the data saved. And there we go. We have our VSC, and now you can see that everything has been changed. And this is also command line 16, and this is command line 8. Okay, so we can also close this off anytime we want to. So now we are back on our Jupyter, and now if we go off to the running section, you can see Python 3 IPY kernel is running, and this is the notebook. And the language server is basically empty because we are still working with Python 3, and Jupyter is basically for Python. Okay, and we can also shut them down anytime, but we want it running. So now if we go off to our files, we are going to create ourselves an algorithm file. Okay, so click on new, and we're going to go off to our notebook, but you can also work on with a console or maybe a terminal. You can also create up a new file if you want to. But I'm going to create another notebook, which is going to basically help me to already work up with Python. So what I'm going to work with is in this class is going to be Scikit-learn and also data sets, because we are also going to be working with data sets. Okay. So first thing, what I want to do is that I'm going to type in from, let's just take it on the first line, from, let's say, Scikit-learn, which is also going to be there. Or if you have not downloaded Python already, I would suggest you go download Python and also install it on your device. It's basically very simple. If you didn't check that video yet on my intro, so what you're going to basically do is that just type in download Python, and you're going to try downloading Python from python.org and try downloading the latest version, which is going to be Python 3.12. Make sure not to download any versions below 3, because Python version 2 is not that flexible, neither that comfortable, not also convenient with the updates and the bug fixes. Okay, so download this 3.12. Even if you are on a different OS, maybe you're using Mac OS or Linux, whatever you use, you have these links over here. Just select up your one and then just download it and install it on your device. And if you have it installed on your device, you're already going to have Scikit-learn, which is a basic data set. And there's like a lot of data sets inside. So I'm going to import up that specific data set inside of Jupyter. So I'm going to import up data sets. Okay. So that is basically it. And I'm going to end my command line, hit on shift and enter. And it has already, detected up the value. Now I'm going to put in iris data sets. There we go, data sets. And make sure to put in that underscore. And then what you're going to basically do is that you're going to put in an equal over here. And then you're going to put in data sets. You're going to load them up too. Okay. So to load them up, you're going to put in data sets. Then you're going to put in dot load. And then you're going to put in underscore iris. And open up and close the parentheses at the same time and hit on shift and enter. And you'll basically see that it is running. So the last thing what I want to do is work up with specific values such as X or Y or Z. But I'm going to be working with the X value. So if I put in X equal, let's say I'm going to put in equal, and I'm going to put in the iris data set, iris data sets. Let's say I'm going to put in iris data set dot data. And then you're going to put in, let's say I need a specific value. So if I put in the second bracket, you're going to start off with a colon, and I'm going to do is put in a comma, and then you can put in a specific another value, maybe like 2, 3, whichever you prefer. So maybe I'm going to work with 2. So I'm going to close off the second bracket here. And basically we're done with our third command line. And you can see we have this name error. So if we have this name error in line 6.1, you can already see that there are a couple of lines missing, but you don't have to worry about it because couple of line is already done with Jupyter, because those are basically machine learning. Okay. So you can see Anaconda Assistance is also over here. So name iris data sets over here. So I'm going to do is going to put in data sets. There we go. Hit on shift enter. And there we go. We have no problem. So if I put in, let's say maybe X underscore, let's say count value is going to be equal, put in equal, and I want to use a specific function. So maybe I want to use the length function. So if I put in length, open up the parentheses, and you're going to put in the value of that axis, such as X dot flat. Maybe I'm going to use the flat value. I'm going to close it off, hit on enter, and you're going to put in, you can also try on shift enter if you want to run up the whole thing. But if you don't want to run up the whole thing, what you can do is put in more commands, such as maybe X minimum, X maximum, X mean value, median value, whichever you prefer. So maybe I'm going to put in a minimum and also a maximum value. So maybe if I put in X, maybe min, which is going to be the minimum value, I'm going to put in equal, and then you're going to put in your values such as x over here, and then close on or open up the second bracket, put in a colon, put in a comma, put in a bit of space, close, and close off the second bracket. And after I close up the second bracket, you're going to put in dot minimum and open and close up the parentheses, and you're going to put in a minus value, minus maybe 0.6. That's the value which I want. Hit on enter, and the last one or the last line which I want to create is going to be the x maximum. So I'm going to put in x underscore maximum equal x, open up the second bracket, open parentheses, or not parentheses, a colon, comma, 0, close of the parentheses or close of the second bracket, and dot max, open parentheses, close the parentheses, minus, and then it could be plus this time. So if I put in a plus value this time, and if I work with maybe 0.5 or maybe 0.6, whichever you prefer. So if I hit on shift and enter, and I'm going to go off to the last line. So here I'm going to put in x underscore count, and I'm going to put in a comma. And if I put in x underscore minimum, I'm going to put in another comma and x underscore maximum. Hit on run, and you're going to get that specific value. So for the count value or the flat length, we have 300. On the x-axis minimum value, we have 3.69. And on our maximum value, we have 8.5. Now, it's going to be depending on different values. So if I put in 7 over here, and if I run out the whole thing, you can also see sometimes it's going to be a bit different. So if I, instead of that, if I put just, a different value, or you have to basically, work with different values at separate times. So maybe if I put in 1 over here, shift and enter, and even if I put in 1 over here, shift and enter over here, the value is obviously going to change. Okay, and these values, you will basically not be able to work with it from directory, because these are a couple of data sets which is going to be there with your Python file when you download it or install it on your device. So these are like basic algorithms which you can work on with, let's say, Jupyter, and also a couple of other IDEs. And let's say maybe I'm going to do is going to be changing up this file, and I'm going to put in, let's say, algorithm. Okay, now if I rename it, and obviously I'll be able to work with it from other IDEs too. And how are you going to do that? So basically this is already saved. Okay, so if I refresh up this page, refresh, and obviously it's still going to be there because it is autosave. And what I can do is open up the file again, and there we go. We have algorithm IPYNB, which is IPython. Now, if I open it up on my IDE, it will also have the same values. So if I go off the algorithm, there we go. We have it over here. So maybe if I put in 1, and if I hit on shift and enter, there we go. We have this over here. And if I work with this over here, maybe x count underscore count, comma, x underscore x underscore max, comma, and x underscore minimum. So if I run up these values, and you can see, there we go, we have no values yet because the instance is still working on Jupyter. So I have to put in that value. I have to put in maybe a specific value over here. I'm going to put in x underscore count, comma, and I can also print out only one value if I want to, such as this. If I want to work with a second command line, if I put in the minimum value only, it's going to be the minimum value. And if I put in x maximum count, I can also work with that specific value only. And you will also be able to work with mean values. If you want to work with mean values, you just have to term it over here. Maybe if I put in x mean, put in an equal, and then x, open up your second bracket, and then maybe this colon, comma, 0, close up the second bracket, dot mean, open and close the parentheses, And if I work with the mean value, maybe I'm going to work with x underscore mean value. There we go. Shift and enter. There we go. X mean over here. X mean dot mean over here. MEAN. There we go. We have the mean value, but we don't have anything over here. So I'm going to close off one line. And if I play this over here again, and if you still see the error, what you basically have to do is obviously you have to rerun the whole thing. And obviously when you rerun the whole thing, and then it's going to give you out that value as the answer. So now you know about the basic algorithms which you can work with, Python in Jupyter. And you can also derive it into your own IDE. Maybe you're using PyCharm or maybe VSC or Notepad+, whichever you prefer, okay? In our previous class, I've shown you a couple of algorithms and how you can get the data sets. In this class, I'm also going to be showing you a demo of Iris dataset of how you'll be able to also use a couple of basic Python codes and also how you can get that data in a visualization. So make sure not to skip any part because there's going to be a lot of codes which I'm going to be using. And I'm also going to give those codes in my resource file, which you'll be able to work with and also use on your own. So without any further ado, let's move into our class by opening up Jupyter on our web browser. So as you can see on my screen, I have already opened up Jupyter. Now, host, what I'm going to be creating right now is going to be another file or another notebook. So I'm going to click on new and I'm going to create another notebook so that I can import all my commands inside of it. So first thing, what I want to do is that I'm going to change up the name of the file, and here I'm going to put in Iris dataset. Okay, so this is going to be the name of this specific file. And the first thing, what I want to do is that we have to check a couple of the version of our libraries. Well, if you worked with Python, you already know about the command, which is sys.version. Now you can also try putting it inside of VSC code. Well, obviously you have to put it inside of the terminal. So you have to go to the terminal, new terminal, and then you have to put in something like sys.version. Now, after you hit on that, you will basically get a command or you will get the version name. But if it does not work, you don't have to worry about it because we are still working inside of the algorithm, which is basically a notebook. So what you basically have to do is make sure that you are working with Python 3. So first thing what you have to do on your IDE is that make sure that the text or whatever you are running is running on Python, as this is not a Python file. This is just a text file. Okay, but as this is working on Python, well, if you are also working or if you already worked with PyCharm, well, you can try putting in the command. So first thing, what I want to start with is going to be the command is to check out the version of library. So I'm going to put in check the version of libraries. Now hit on enter, and I'm going to put in hash again. I'm going to put in Python version. Now I have put in these, but obviously I did not put in my commands yet because now I'm going to import them. So I'm going to put in import, and what I'm going to do is going to be typing in sys because of the system. Import system. And now I'm going to import it as print. So I'm going to print, open up the parentheses, and inside you're going to put in 1 colon, and you're going to put in Python colon over here. And then you're going to put in the third bracket, not even the second bracket. Let's just close this off. Third bracket, and close up the third bracket again, and close off the parentheses or close off the quotation. And after quotation, you're going to put in dot format, You can see dot format, and then you're going to open up the parentheses and you're going to type in sys dot version. Okay, close the parentheses 2 times and you can hit on enter or shift enter to play it out. And you can see we have Python 3.12. So just like I showed you on the web browser that this is the latest version, and I would also suggest you try using that specific version. Now here I'm going to create a couple of them, but obviously all of them are going to be a bit different. But right now I'm going to create like 4 more, which is going to be Scrippy, NumPy, then Matplotlib, and also Pandas. And the last thing what I want to do is about Scikit-learn. So I'm going to copy up this one, Control C, copy it a couple of times, hit on enter, paste it. Now I'm going to paste it like a couple of times, on enter, 2 times, 3, 4, and 5. There we go. Now after each and every one of them, I'm going to create myself up a variable. So I'm going to put in hash. So for this one, I want to use Scikit-python. So I'm going to put in SCI and then PY. There we go. Scikit-python. And inside, you're also going to put in Scikit-python. So I'm going to put in SCI-PY. There we go. And over here on format, you're going to put in scipy.version. And you're going to also put in underscore just the way I do it. Okay, so make sure to do that. You can also remove out these parts if you don't want to, because the rest of the ones are going to be quite similar. So I'm going to put in SCI Python, and then you're going to put in dots, and after that you're going to put in an underscore just like this. So after the underscore, you can also put in double underscore if you want to, but you can also work up with 1 underscore, but you can also put in double underscore, which is also going to be quite okay. So there we go. We have created another one. You can see import sys. You're also going to change it into import scipython, and we also have this over here. So for after this, we're going to be creating a couple more of these variants. So I'm going to 3 times and then 4 times. So let's just change out these values first. The next one, what I want to do is NumPy. And the next one after that I want to use is Matplot. So I'm going to put in mat. There we go, Matplotlib. And the next one I want to do is Pandas. And the last one, which I want to check, is going to be Scikit-learn. So there we go. We have all of these variables. And now what we're going to do is going to be changing out these ones too. So I'm going to put in NumPy. And you're also going to be changing out these values inside. You can see over here, NumPy. And you're also going to change this value over here, NumPy. Okay, you're going to do the same thing on each and every one. Let's just copy this. Control C, Control V, Control V, Control V. That's it. Let's copy up this one, Control C. There we go. Do the same thing which I'm doing right now. It will be a lot more easier and a lot more faster. Okay, Scikit-learn. There we go. We have created and also changed every one of them. Now, what I want to do is that I want to just play the whole thing. Now, if it doesn't work, what you basically want to do is that remove out one of these underscore, okay? But obviously, you're going to see the results and it will give you out the versions which you are using as the versions of Python. So as we got our versions, now we want to load in the libraries such as Pandas, Pandas plotting, scatter matrix, and etc. Well, this is going to be quite a large code of, or let's say a large code line. So I would suggest you make sure not to skip any part. So I want to start off with a variable and I want to load in the libraries, which I will be doing. So I'm going to do is going to be load libraries. There we go. Now, what I want to do is that I'm going to import up my pandas at the beginning. So I'm going to import pandas, and I'm going to start off importing from where I want to import my pandas. So I want to import it from pandas.plotting. Now, after that, I want to import scatter mix too. So I'm going to import up scatter, then underscore matrix. Now, this is going to be my second line. Now, I want to import Matplotlib. So I'm going to import it, Matplotlib. There we go. Make sure that, whatever you put are the alphabets or whatever word you're using, all of them are going to be very case sensitive. So make sure it is accurate. So I'm going to import matplotlib.pyplot. Okay. .pyplot. So after that, what I want to do is that I want to import it as PLT. There we go. As a plot. Now I want to import it from Scikit-learn. So there we go. We have it from Scikit-learn. Now I want to import model selection. Import model underscore selection. There we go. Now I want to import it from Scikit-learn metrics. So I'm going to import it from Scikit-learn. And then you have to put in dot metrics. There we go. Now, as I've put in the metrics of Scikit-learn, I want to import classification report next. Import. I want to put in classification underscore, and then you want to put in report. The next line, I also want it from Scikit-learn metrics. So I'm just gonna copy up this one over here, this line. Scikit-learn metrics. Now the next thing what I want to do is confusion metrics. So I want to import it. Confusion underscore matrix. Paste up that again. You can see confusion metrics and Scikit-learn metrics again. And I want to import it from accuracy score. Import accuracy underscore score. The next line, what I want to do is also from Scikit-learn metrics, or let's say I'm going to put in Scikit-learn.linear model this time. Linear underscore model. Make sure there is an underscore, and you're going to import it from logistic regression. Logistic regression. Then I'm also going to put in Scikit-learn tree. So I'm just going to put in Scikit-learn.tree. Import it from decision tree classifier. Decision tree classifier. There we go. And the next one, what I want to do is Scikit-learn neighbors. Now I want to import kneighbor classifier. Import kneighbor classifier. There we go. The next one, what I want to do is Scikit-learn.discriminant analysis. Scikit-learn discriminant discriminant underscore analysis, import linear discriminant analysis. There we go. The next one, what I want to do is I want to also get it from Scikit-learn naive base. Naive underscore base, import from Gaussian and B. And the last one, what I want to import it is from scikit-learn.nvm. You can see our SVM. Let's just use SVM instead of NVM. And I want to import it from SVC. So basically, we're done with this. So I'm going to hit on Shift and Enter. There we go. We have loaded up that specific libraries. And you might see these type of errors sometime. So one thing what I want to do is that we have this scatter matrix. We have double T. So I'm just going to remove one of this. And now if I play it out, there we go. It has been fixed. Okay. Now, after that, we want to put in our URLs from where we want to get in these specific values. Obviously, we're going to use any specific URL. So in this class, I'm going to be putting in our URL, which is going to be very common, which you can also try using. So you're going to put in URL equal to any specific value. So I'm going to put in double quotation HTTPS. And here I'm going to put in this / 2 slashes. I'm going to put in an archive. So there we go. We have archive.ics, then uci.uci.edu/ml, which is for machine learning. There we go. I'm going to change this ICS UCI edu/ml for machine learning / and you're going to type in machine, then you're going to put in, let's say, a dash, and then you're going to put in learning, and you're going to put in databases, and you're going to put in the iris value, iris / and you're going to put in iris.data and put in or close off the double quotation. Now, after that, what I want to do is I'm going to work with names. So here we go. We have a couple of names which you can work with, but I'm going to be working with specific numerical values and also specific values. Maybe let's say I want width, I want length, I want a specific class, because that is the specific data of that specific resource. Okay. So I'm going to put in, let's say, names. After that, I want to put in, let's say, a secondary bracket or a square bracket. And I'm going to start off with one quotation this time. So I'm going to put in sepal length. There we go. We have sepal length. Close off one quotation, comma, one quotation again. I'm going to put in sepal width, one quotation again, comma, and you're going to put in petal length, one quotation, comma, petal underscore, or let's say dash, width. Close off the quotation. And the last one which I want is going to be the class. There we go. Close off the quotation and close off the second bracket. Now, after I have done that, what I want to do is I'm going to also import up my data set. So if I put in data set, which is going to be equal to, let's say, pandas dot read, and then you underscore, you're going to put in CSV, and then open up the quotation, like open up the parentheses, and you're going to put in the URL, which we already have, comma, names equal to names. There we go. Close off the parentheses, and now you can run out the whole thing, and obviously it will give you out that specific data. But you're going to put another line of command. You're going to print out the specific data. So maybe I want to print out, let's say I want data set of shapes. So I'm going to put in data sets dot shape. So if I now play it, you can see this is the exact data shape. So maybe what if I want the data set of a specific header and I want 20 specific values? So I have to put in print, and then I'm going to close off the parentheses or open up the parentheses, and I'm going to put in data set dot header. There we go. We have our head, but what data do we need? So I only want 20 values. So I'm going to close that off. And if I shift enter, there we go. We have 20 values starting from 0 to 19. So for 20 of these values, we have the sepal length, the sepal width, the petal length, the petal width, and also the class. So this is that specific class. So if I just change in the sepal, let's say maybe I want to sepal base. So what if I play this whole thing again, and if I play the whole thing, you can see the sepal base or the base of that specific value has also changed. So if I just put in, instead of that, maybe I want to work with sepal area. Shift enter, shift enter, shift enter. Now you can see we have the sepal area, but the value has obviously changed. It's because it is using machine learning to actually get out that specific value. If I want to work with 30 values, what I basically have to do is just change the numerical value over here, shift and enter. There we go. We have now 30 values. Now I want a description of this data set too. So I'm going to put in print, and then open up the parentheses. I'm going to put in data set, and then you're going to put in dot description. So if I put in description over here, and if I just close the parentheses, that's it, shift enter, and there we go. We have maybe an error of a data frame, object has no attribute description. So obviously you have to also put in the description inside too, which is obviously going to describe out these values. So now what I have to do is that you have to obviously add in a description. So here, let's say maybe I want a description, comma, and colon, description, colon over here. Now if I play out the whole thing, and now you can see we have these specific values. But now you can see print dataset dot description. If it still does not work, what you can obviously do is that you can just describe what you want. So maybe I can also put in describe, and if I just shift and enter, and when I use describe, and you can see now we have the description. Sepal area, we have the description. We also have the description, which is 0 over here. So there we go. Even though we put in a description over here, obviously it only got the first one, which is the count, which is 0.00. So this is how you can use this specific value. Now, another one which I can do is that we can also get in the group or maybe the class. So if I want to get a specific class, which I have over here, you can see we have setosa over here, iris setosa. Most of them are iris setosa. So what if I want to get more values of these? So maybe I can also put in print, and then I'm going to open up my parentheses. I'm going to put in dataset dot group by. So group by, I'm going to close off the parentheses, quotation, class, close off the parentheses. I'm going to close it off because I have put in my variable, which I want to use, and I want it to be sized. So open and close the parentheses and close the parentheses at the end, shift and enter. And you can see, there we go. Again, we have this error, or this is the type of error you might face. Now you can see when I have put in dataset group by class and also the size, there we go. We have our class. You can see iris setosa is 50 of them, versicolor is 50 of them, and also another 50. So if I just put in that specific value, if I want all of them, maybe I'm just going to remove out all of these values. I'm going to close out the parentheses, hit on shift enter. There we go. We have a lot of these values. And now the next one, what I do is just shift enter, and also shift enter. There we go. Now we're going to have a lot of these values, such as iris setosa, iris virginica, and a lot of them. Okay. So there we go. Now you know how you'll be able to use iris datasets, or how you'll be able to use machine learning to actually import up your data and also use it inside of Jupyter. So hope you understood everything about this class on how you're going to use Jupyter and how you're going to use Python for machine learning, how you can get an exact data which you want, and also how you'll be able to interact with these commands. And obviously, I'm going to put in both of these command lines inside of my resource folder because it will be a lot more easier for you to learn. Okay, so thank you for watching this video again, and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. In this class, we're going to try to give you out the best example, the best idea, and how you can use your codes of command. In this class, we're going to cover everything you need to know about the basics of linear regression and also the calculation of R2 or R squared. Now, before getting into our class of learning about linear regression, we have to know about what linear regression is. So linear regression is a statistical method used to model the key relationships between a dependent variable and one or more independent variables. The goal is to establish a linear equation that can predict the value of dependent variable based on the values of the independent variables. Now, let's check out the key concepts of linear regression. First one is simple linear regression. Now, each of these key concepts are going to have its own equations. But let's check out the simple linear regression equation, which is y equals to beta 0 plus beta 1x plus epsilon. Now here we have the y value. The y value is a dependent variable, so it's going to depend on what value it is already choosing. X, which you already have over here, is an independent variable, so you will be able to change it anytime you want to. Then we have is beta 0, which is basically the interception or the intercept, where the value of y when x is 0. So if the value is 0, the value of y is going to be the intercept. Then we have is beta 1, which is also called the slope. This is the change in y for 1 unit change in x. So if it changes, let's say from 0 to 1, it's also going to change. If it changes to 2, it's also going to change. So every unit that changes is also going to change the beta 1 slope. And the last one we have is epsilon. So epsilon basically is termed for the error term. This is the difference between the observed and also predicted values of y. Obviously, we are learning about machine learning. So none of these values, which you can see over here, except for y, is going to be variable and also can be changed anytime. But all of them are going to be predicted values. So everything is going to depend on what independent values you use and that independent value is going to change all of the values inside of that equation. Then we have is multiple linear regression. The equation for multiple linear regression is that y is equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus, and then it could be like different variables plus beta n xn plus epsilon. Here, there are multiple independent variables such as x1, x2, and also xn, which is also just a figurative speech or a figurative number. So it could just go on depending on what values you are working it with and also which data set you are working with. So now you know about these equations which you can use in multiple and also single linear regression. And all of the criteria is going to be the same, where beta 0 or beta 1 is still the slope and beta 0 is the intercept. Then we have is assumptions. Linearity. The relationship between the dependent and independent variables is also linear. Well, when I go to my practical classes after this, lecture, or after, knowing or getting the idea about linear regression, we're also going to show you a couple of practical things which you can apply on your own. So you're going to get that example there. Then we have is independence. Observations are independent of each other. Homoscedasticity. The variance of the errors is constant across all levels of the independent variables. So the variance is also going to depend on which independent variables are you using or which data set you are using. Normality. The errors of the model are normally distributed. Now let's check out number 4, where we are going to talk about interpretation. Where we have is coefficients, where the coefficients is basically determined with the beta sign. It represents the magnitude and direction of the relationship between each dependent variables and also dependent and also independent variables at the same time. Then we have is r squared, which we are going to show you in the code of conduct. And also I'm going to show you by coding, which indicates the proportion of the variance in the dependent variable. So that is predictable from the independent variable. So it's going to change from time to time. Then we have is the p-value. It tests the null hypothesis that a coefficient is equal to 0 and no effect. So that is basically the interpretation. Application. Predictive modeling. Forecasting future values based on historical data, where trend analysis. Identifying and measuring trends over time. Risk assessment. Estimating the impact of various risk factors. So now we know about the key concepts. So let's just come up to the summary. So basically, linear regression is widely used due to its simplicity and also its effectiveness, especially when the relationship between variables is approximately linear. It forms from the foundation for many more complex statistical and also machine learning methods. So now let's just get into our practical classes of how we can calculate our R-square and how you can show linear regression by coding. So let's open up, let's say we could open up any IDE if you want to, but I'm going to be using Anaconda Navigator so that I can open up my notebook of Jupyter. As you can see on my screen, I have opened up Anaconda and I'm going to open up Jupyter on my device. So just make sure that you have internet connection so that you can create yourself up an instance. And after you open it up, it's going to already pop up on your screen. So I'm just going to open it up over here. And there we go. We have Jupyter. So first thing, what I have to do is that I'm going to create myself another file, which is also going to be a notebook so that I can start coding. So what I'm going to do is just click on this new over here, click on notebook, and it's going to create myself that notebook. And obviously I'm going to change the name of this so that I can work with, let's say, I'm going to name it calculation of. So this is going to be the name, which is going to be the calculation of R-square. So first thing, before actually going into linear regression, we are also going to find about the calculation of R, okay? But first thing what we have to do is that we have to put in or import a couple of datas or a couple of CSVs. So first thing what I have to do is start off over here. I'm going to put in, let's say, a percentage, which is going to actually redirect my Matplotlib. So I'm going to put in Matplotlib inline. There we go. And now you're going to import up specific data. Let's say I want to use NumPy because I'm going to be also showing R square and also linear regression. And I want to import NumPy as an NP. So I'm going to put in NP and then I'm going to put in import. The next thing what I want to import is Pandas. And I want to import it as PD. Now, the next one, what I want to import is obviously one of the main part, which is going to be the Matplotlib, because this is what we are using as a variable. So I'm going to put in Matplotlib and obviously dot Python plot, which I'm going to be using, and I'm going to use it as PLT. Okay. Now, what I want to do is that I want to plot up certain commands, such as RC params. So I'm going to put in RC parameters. There we go. Plot RC params. And then I want to use a figurative speech. Let's say maybe like a figure size, which I want to use. So I'm going to put in single quotation. And here, what I'm going to be doing is going to be putting in figure dot fixed size and close off the quotation. And you can also close off the parentheses or the second bracket, whichever you feel comfortable, equal. And then I'm going to put in a quotation, or not a quotation, but a parentheses. And here I'm going to put in, let's say, maybe 21.0 as my size. And I'm going to put in, let's say, 11.0 as the other size. Okay, so there we go. We have that. And now I'm going to put in a reading data. So I want to read specific data too. So I'm going to put in reading data. And I'm going to put in data equal to pd dot read. I'm going to read out that matplotlib file. So I'm going to put in pd dot read underscore CSV. So this is the CSV file which I'm going to be working with. Open up the parentheses, quotation, and you're going to put in, let's say, maybe I want headbrain dot CSV. So this is the file which I want to open up. And there we go. And I want to print out that specific data. So print open parentheses data dot shape. Okay, close up the parentheses, and I'm going to put in data dot head and open and close the parentheses. So basically after that, now if you want to find out using the equation, first off, you have to create yourself another variable. So after creating that variable, you're going to put in collecting then x and y values. Let's say I'm going to put in x and y. So here I'm going to put in x equal to data and open up the second bracket. Let's say I'm going to work with a specific size. Maybe I want the head size. So if I put in head size, let's say open up the parentheses, centimeter. And when you want to cube it, you have to put in this sign. And then you have to put in, let's say maybe I want to cube it. So it's obviously going to be 3. And now I'm going to open or close off the parentheses and also close off my quotation and then close off my second bracket. And then I'm going to put in values. Okay. So this is the values which I want to work with, and y equal to another data, which is also going to be the head value. So I'm going to put in, as I've worked with head value, now I want the brain value. So if I want to use the brain value, I have to put in brain weight. So I'm going to put in brain weight and then open up the parentheses, and I'm going to want it with R2 grams. So this is the grams which I want to be using, and then close off the single parentheses and close off the second brackets on the second line too, and then put in values. Okay, this is all you need, and you can press on Shift and Enter. So you can try running it, but sometimes you might face an error like this. So if you basically see an error like this, what you can do is import a database from Pandas. So first thing what you want to do is that, let me just cut this off. And over here, you're going to put in, let's say, import Pandas. Now, after import Pandas, you have to import as PD because this is a Pandas file. And here we're going to create another data frame for us to actually create the sample. So here I'm going to put in a hash. I'm going to put in creating a sample data frame. So here I'm going to be using an extra data frame like related to what we want to use. So here on the data frame, I'm going to put in maybe data equal. Now you're going to put in the third bracket. And here you want to create it inside of that, indentation level because you want the data inside of it. So here you're going to work up with the same commands. Maybe I want, let's say, head size. So the head size which I want to use is going to be obviously inside the parentheses cm. You can use centimeter cube. We're going to be using the power like symbol. Let's say I'm going to cube it, close up the parentheses, single quotation, and open up the this colon over here and open up the second bracket. And here you want to work up with specific values, maybe 100, 200, comma, 300, comma, 400, comma, 500. So these are the values which I want to be working with. And now I'm going to put in the brain weight. So I'm going to put in brain weight. Now here you are also going to be putting in grams, just the way I did over there. Close off the parentheses. And here you're going to close off the quotation with a single quotation over here. Open up the colon. And here you also want to put in specific values. So this one I wanted, let's say, maybe on my brain weight. And over here, I want to work with simple values such as 1, 2, then we have 3, 4, comma, 5. So these are the values basically which we'll be needing. And right after that, we're going to hit on Enter, and we're going to close off our third bracket. There we go. And now I'm going to enter my df, which is going to be the data frame. So I'm going to put in df, which is equal to our pandas data frame. So pd dot data frame, and I want the specific data. So these are the data which you want to be working with, and I'm going to create another variable. So hash collecting our x and y axis, our x and y variable, which is going to be dependent and also independent variable. So here I want x as our data frame, such as the same ones, data size and data values. We can also copy it from over here, Control C, Control V. There we go. These are the values which we need. And then you can just enter. And you can see sometimes we might have this syntax error. So here we're going to check out, where we basically have the error, or basically where we have, a problem over there. So basically, let's just try rerunning the whole thing. And after you rerun it, you'll basically see the error has now been fixed. Okay. So this is basically how you're going to import up specific data inside of your console. Now, there are also a couple of different ways of getting the mean value of x and y. So first thing, what you want to do is start off with creating another variable, and you're going to put in the mean value, mean of x and y. There we go. And I'm going to put in the mean underscore, let's say, x equals to the NP. So NP dot mean of x. There we go. This is the mean of x. And then I also want the mean of y, mean underscore y, equal to, let's say, np.mean. And here you want to put in parentheses and y. Okay, but you also have to create like a lot of these variables. So basically you can try playing out these values. It's obviously going to be read and it's obviously going to be termed out. Okay, so you can also use this, Jupyter assistance, which you can run with these values. Okay, if it shows you an error, you can just copy it and paste it and check out where you have your error. So this is kind of very convenient to have as an assistance on a couple of IDEs, even on notebooks. So basically you are running it on an instance of your own environment. So you don't have to worry about it. You can practice on your own and you can also get like specific values. So here, instead of ending up that line, what I want to do is that I want to use specific printable values. So if I want to use specific printable values, we have to work up with a couple of, let's say, coordination. So here, maybe I want to use another variable. So I'm going to use total number of values. And I want to use the n value here. And I'm going to use my length function, length of x. So we have put in our length, and I'm going to create another variable, which is going to be using the formula to calculate b1 and b2. Using formula to calculate b1 and b2. There we go. Number, I'm going to use numericals, which is going to be 0 value. And I'm also going to be using denominators, which is also going to be, let's say, a value of 0. And you don't have to turn it into strings or anything because, this one is obviously termed as a number. So there we go. We have denominators and also numericals. So here, what I want to do is that I want to import it for I in specific range value. So inside the range of m. So this is the range which I want to be working with. And here I want the numerical value, which is going to be plus or equal to the value of parentheses x, open second brackets, and I want to use I as my value, I minus mean value underscore x. Close off the parentheses. We are almost done on this part. And then you're going to multiply it with another variable, which is y. And then you're going to put in I, second bracket, close. And you're going to put in minus with the mean of y. Mean underscore y. Okay, so that is basically what you want to close it off with. And then you're going to work up with denominators. So I'm going to put in denom plus and also minus. It could be plus or equal to. So I'm going to put in plus or equal to the same type of variable, but it's going to be multiplied with 2. So I'm just going to copy this part over here. Control C. And I can just paste it over here. And you're going to put in 2 asterisk sign, and you're going to put in another value. So there we go. We have that value, and we're basically done with this, line of commands. And you can put in b1, which you want to work with as the equation. So you can put in numer, and then you're going to put in divided by the denominator. And on the last one, you want to work up with beta 0 or b0, which whatever you feel comfortable saying. So I'm going to put in mean underscore y, and then minus value with the specific value of beta 1 multiplied by mean of x. So you can put in a parentheses, beta 1, and multiplied with mean of x. There we go. We have another command line ready. And now you want to print in the coefficients. So I'm going to put in another variable, print coefficient. And then I want to print beta 1 and also beta 0. So I'm going to put in maybe B1, comma, B theta or B0. There we go. So basically we have it. So after here, you just want to like open up and you can see we have our specifical values identified. So this is basically how simple it is to work up with these coefficients. Now, after that, what you want to do is that you want to show a specifical plot value as a legend or maybe as a label. So if you want to do that, you also have to create a couple of regression lines. So here I'm going to be working up with specific values, and obviously whenever you run up these commands, you can also run it up on the Anaconda Assistance, which is also going to give you out that specific value. You can see it is also the same one which I've used, and there we go. And you can also change a couple of things if there are a couple of errors. You can see length x, it's also the same using formula to calculate b1 and also b0, and also all of them are in same. Okay, so now what I want to do is the only thing that I changed over here is this line over here. You can see B1, this, and then mean X. Okay, so now let's open up another code of command. So let's start our Matplotlib. So we want the linear regression in, let's say, a graphical form. So first thing what I want to do is that I want to import my matplotlib.python plot. So I'm going to put in matplotlib, and then you're going to put in .pyplot. And here you want to import it as a PLT file. So here we go. And now one thing what we have to do is that we have to assume the previous code for calculating b theta, which we already did over here, and also the b1 values, and also the independent and dependent value is already executed and it is already here. So we can put in something like assuming the previous, let's say I'm going to put in assuming the previous code for calculating B0, B1, comma, and defining. So I'm going to put in, let's say, defining X, comma, Y is already executed. Okay, it is already executed. So here, what I want to do is that I want to find out the max value and also the minimum value of X. So I'm going to put in max of X, which is going to be equal to np dot max, and inside the parentheses, it's obviously going to be the X value. And inside my X value, I want to add it up with, let's say, 100. X added up with 100. I'm going to put in minimum value of X equal to np dot minimum of X, and I want to minus it with the specifical value 100. Okay, both of them, the indentation level should be the same. It should also look good and also work better. So here I want to create the variable which is going to be calculating the lines of value X and Y. So I'm going to put in calculating line values X and Y. There we go. And here I want to put the X value, X equal np dot, let's say, line space. There we go. We have the line space over here. Open up the parentheses, which is going to be minimum X, comma, maximum of X. Okay, so minimum and maximum of X, and I want the specifical value to be, let's say, 1000 inside of 1000. And here in the Y value, which is basically the variable, and it's going to be depending on the X. So according to the equation, it's going to be B0 which is singular line of regression, plus b1, and you're going to multiply with x. Okay, so this is the line, or this is the equation, and now we're going to create ourselves up a plotting line. So here I'm going to put in plotting line. There we go. We have the plotting line right now. So I'm going to put in plt dot plot. And after that, I want to put in my variables inside my parentheses, such as x, comma, y, comma, and c as that. I'm going to put in equal. And then you have to put in certain variables, such as you're going to copy this. Okay. So you're going to put in maybe a hash. Then you're going to put in 58b970. This is a specific directory to that specific database which you want to be looking for. And you're going to put in a label to this specific value. So I want to label it as a regression line. So I'm going to put in regression line. Close it off. Close the parentheses. And the next one, what I want to work with is basically called the scatter points. So I'm going to put in a hash value. And I'm going to put in, let's say, plotting scatter points. There we go. I'm going to put in plt.sch scatter. Open up the parentheses, x, comma, y, comma, c, equal to, let's say, open up the parentheses, the hash value. And inside of the hash value, you're going to put in EF5423. So this is the specific value, or the specific directory, comma, and then you're going to label it as scatter point. So the label which I want to be working with is going to be called scatter plot. There we go. Close off the parentheses. And now we want to put in a couple of these variables, or a couple of these commands. So I want to plot up, first off, x label, y label, and I want to show the legends, and I also want it to be shown inside of my notebook. So I'm going to put in plt.xlabel, xlabel, open up the parentheses, and you're going to put in, let's say, the head size in centimeter cube or 3. You can put it like that. Now you're going to put in plt.label.ylabel first. Ylabel, open up the parentheses, and this is going to be the brain size, or brain weight in grams. And the next one, what I want to do is I want to show it in labels. So I'm going to put in plt.legend, and you're going to open and close the parentheses. That's all. Legend over here. And you're going to put in plt.show. Open and close the parentheses. So basically that's it. You're just going to play out the whole thing. And there we go. We have our regression line and also our scatter plots. So according to the data, you can see the scatter plots are all together and is on a linear scale. And the head size is basically on over here. And sometimes like the database variable and which directory you are using, it's going to vary from time to time. Sometimes you might see the scatter plot is going to be a lot bigger and there's going to be a lot of dots over here. So it just basically like differs from time to time, like which value you want to work with. So you have to keep that thing in mind and then work according to which command line you want to work with. So hope you understood everything about this class, or this part of the class, because this is going to be a long class. And then we're in the next part of this video, we are going to be showing you how you can put in your own commands to actually calculate the value of R squared. So thank you for watching this video up till the very end, and hope you understood about everything. So now let's move on to the second part of regression line and also calculating the value of R squared. Welcome to part 2 of linear regression and calculation of R squared. In our previous class, or in our first video, we have learned about how we can visualize linear regression in graphical form. In this class, I'm going to show you, and I'm also going to give you out the brief of the calculation of R squared, which calculations are used, and what does the value mean. And after those briefs, I'm going to show you how you can use the code of command or the command lines and do a bit of coding on them, and how you can get out those values, such as getting 0 and minus values and also 1, and what does those numerical values stand or indicate. So without any further ado, let's open up Jupyter Notebook on my device. So you can see on my screen that I'm using the similar file which I've used of this video. So you can see on this screen before getting into this class is that we have this value, we have the regression line, and also the scatter plots. So let's say, or let's just come to the conclusion that scatter plot is basically the data, and the regression line is basically the line where it basically indicates if the scatter plots are in the line, it basically means that the data is perfect. But sometimes you might see in these type of visualization, the scattered data might actually be scattered and could be like a lot further away from this regression line. So let's just know, or let's just start off knowing by what the calculation of R squared stands. Let's say in linear regression, the R squared static is a measure of how well the regression model fits the observed data. Now, the observed data is going to be a specific file which you are going to be using as, let's say, the database file. So in this class, or from our previous class, or the part 1 of this class, we have been using several databases from Pandas, Matplotlib, and also our Python files. You can see over here. So there we go. We are using Matplotlib and also, let's say, PyPlots. Okay, so all of these are going to be already included on Python if you actually install it on your device. So you don't have to worry about extra files. But if you want to work up with, different directories or different database files, you can actually download it from online and then actually use it as the directory and the file name, and you can import it on Python and even on Jupyter. So there are a couple of calculation of R squared. So before knowing this calculation, and we don't basically need to know about the calculations at first. One thing which we need to know is that there are going to be couple of equations, and there could be like 4 to 5, but mainly there's like 4. So the first sum of squares, which is known as SST. So SST measures the total variations where y is the actual value. So in our first part, we have known that y is a dependent value. So we're going to be needing y as the answer, or the after result, or the end result of y. So why is it very important? Because y is the exact value from these equations and the mean of the observed values. The next equation is known as SSR, where it is basically called the residual sum of squares, which measures the variation in the observed data, where yi is the predicted value from the regression model. So this is the regression model, and when we use SSR, it's going to predict the value of the regression of yi. And the last one is known as SSE. Okay, so that is a bit different, but the last one which we need to know is about the R squared proportion. So this proportion of the total variation in the observed data is explained by this regression model, where let's say R squared is equal to 1 minus SSR minus SST. So SSR, or which is known as sum of square, is the y, where it is the predicted value of the regression model, where SST is basically where y is the exact value of the mean. So you might find it a bit more confusing and questionable, but After these lectures, I'm going to actually show you how you can get out those values. And before getting into those practical ones, we have to know about the protection or interpretation of R square, because sometimes you are going to face errors. Sometimes you're going to face with different values, such as 1, 0, and then lower than 0, such as negative values. So what does these indicate? So when R square or the value of R square is showing you 1, the model explains all the variability of the response data around its mean, which indicates a perfect fit. So I'm going to show you how you can actually find out that it is a perfect fit. But in this regression line, we can already see that the value we are using is totally perfect, and we are going to get the data of 1. But I'm going to show you when you are working with different and manual axis, or let's say manual, dependent values or variables, you will get different values. Then we have is R square, which is equal to 0. So the model explains none of the variability of the response data around its means. So this indicates that the model does not fit the data at all. Okay. And the last one, which is going to be negative of 0 or lower than 0, is going to be the model which explains some but not all the variability in the response data, where higher values indicate a better fit. So obviously, when we have a higher value, it might also mean that the value is a perfect fit. So how are we going to know that? I'm going to show that to you step by step. Okay, so adjusted R square, unlike R square, the adjusted R square adjusts the number of predictions in the models. It is used to prevent overfitting, as adding more predictions to the model will always increase. Okay, and there is also a limitation of the value or the calculation of R square. So while R square provides useful information about the fit of a model, it does not indicate whether a regression model is appropriate. It also does not indicate whether the independent variables are a true cause of the changes in the dependent variables, nor does it account for potential biases in the model. So by actually learning or understanding R square, you can gain insights into how well your linear regression model explains the variability of the data and assess the overall goodness of fit. So one thing we can see or come to the conclusion is that all the data or the scatter plots is inside the line of regression, which we can already see that this is a perfect fit, and it is also, let's say, it is going to be a better fit too. So let's get into our line of codes. First thing, what I want to work up with is going to be SSR and SST, where SST is going to indicate the mean value of Y, such as this line and also the surroundings of it. And we're going to use SSR, or this variable, as the Y prediction value. So I'm going to put in SST is going to be equal to the numerical value 0, and SSR to be the numerical value of 0, because we are going to be working with 0, not any different values. So for I, we're going to find out the value of I in range, let's say n. So basically the value n over here is the number of observation, and we're also going to be, we can also work with p, but we're not going to be using that in this class, which is also used as the prediction value of y. So here n, we're done. Close off the parentheses and put in a colon, and inside this indentation level, we're going to use the prediction of, let's say, y. Y prediction equals to beta 0 plus beta 1, and then you're going to multiply it with x and I. There we go. Now we're going to work up with the mean and also the prediction of y value. So I'm going to put in SST over here. It's going to be plus or equal to y, which is going to be I value. And here you're going to minus it with mean of y. close of the parentheses, and double multiplication with 2 and SSR plus or equal to y minus the y prediction, y underscore prediction value, close of the parentheses, double asterisk into 2. So basically we are done with the range values, and the range value could be different at different times depending on which file you're using. So here on the R square value, which is going to be 1 minus the value of SSR divided R divided by SST. Close of the parentheses, and now you're going to print out the value of R2. Close it off, play it, and you can see we have the answer 1. So it indicates that the data inside this variable or this database is actually a perfect fit. Now we can also change out the values and it's going to change. So maybe in SST I want to work up with 1. If I play it, there we go, we still have 1. If I work with 2, I will still have 1. If I change it to 3, it will still be 1. Even going off to 100, still 1. Because when we are changing the value of SST, which actually indicates the mean, it is still using the line of regression. But when we are using the y prediction value, then it will obviously change. So if I put in 1 over here, it might change to, or let's say, deduct 1 unit. So you can see 0.9999. So if I just change it to 2, it will change to 98. If I change it to 3, 97, it will just keep on reducing. If I put in 100, it will be like this. If I put in 1000, it will be like this. So depending on higher values, maybe I want to work with just like this or something this random. If I play it, there we go. We have minus 58.87, and higher the value is, the better the fit is going to be. But as this is a prediction value, it will obviously not change according to your own will. Okay, so there we go. I've shown you how you can actually get if your line of regression or the database which you are using, if it's actually a perfect fit. So you can see, or you can come to the conclusion that this is a perfect fit, and no matter how many times or the prediction value changes, it will still be a better fit, because you can already see from the line of regression and also the scatter plots is that all of them are on the line of regression. Okay, so if it was like really scattered, really further away from the line, then it might have shown me 0 as the value, and then it could change. But obviously at like a certain number, it's going to be 0, which is not going to be a perfect fit. But it doesn't mean that it could not be like a perfect fit. Okay, so in one chances it will still be a value of 0, and then you might face an error. Okay, so this is what you should know. And the next thing what I want to show you is about, let's say, an alternative method, but also how you can use, let's say, variables such as x or y or prediction of y, mean of y. If you want to work with different values or with different independent values, then you might see different like numerical values or numerical data. So how are you going to get that? And at that time, you will also see that the interpretation of R square will be changing a lot. So first thing, what I want to do is that from Scikit-learn dot linear model, I want to show or import the linear regression. Now from Scikit-learn dot metrics, import up R2 score. Now I'm going to create another variable, which is I'm going to reshape up the value of the independent values. So I'm going to reshape it, which you'll be able to change anytime. reshaping the value of x. So here I'm going to put in x equal to x dot reshape. Then I'm going to put in open double parentheses n comma 1. Close off the parentheses. And then the next thing what I want to do is that I'm going to create a model. So here I'm going to create another variable, creating a model. Let's say I'm going to put in creating model. That's it. Here in creating model, I'm going to register reg equal reg, or let's say maybe I want to only put linear regression in this line, and I'm going to put out the value in y prediction. So here I'm going to put in, let's say, linear regression open and close parentheses. I'm going to open up another variable, which is going to be used for the training data. So I'm going to put in fitting training data. So the fitting training data, where I'm going to use this to register reg.fit. And here I'm going to put in my independent and also my dependent value. There we go, x and also y. And the last thing, what I want to create another variable is called y prediction. So y prediction. Here I'm going to use y underscore pred, which is going to be equal to reg dot predict, and it's going to be x. Then hash, I'm going to put in calculating R2 score, where I'm going to be using R2 underscore score equal to R2 underscore score. And I'm going to find out which value or which variable I want to get the value. So here I'm going to start off, I need the value of y, and also with the collaboration of y prediction. There we go, we have it. And here I'm going to put in print out R2 score. Now, sometimes what you might see is that if I run it, it might be an error. So you can see, there we go, we have this error over here. But the next thing what you want to do is that you have to run or rerun the whole command line once again. So I'm going to rerun the whole command, and there we go, we have our specific value where we have 1.0. So where 1.0 is basically termed a perfect fit. And we can already see from over here that this is already a perfect fit when we want to use y and also y prediction. Now, what if I want to change out the independent value? Now, one thing you have to keep in mind is that if you use y over here, it's going to be an error because y is not an independent value. So we have to always use x on the y prediction, which is going to change depending on the x. Now, if you want to get out the value of x, then you can also put in x on the y prediction and play it. And there we go, we have minus 4.39. And just like I said, if it is a higher negative value, it also shows or indicates a better fit. Now, what if I want to find out the value of x at first and y last? So if I play it, now we have minus 53,904 0.5. So there we go. We have this value over here. Now, what if you want to work with the y mean value? So if I put in y underscore mean, if I play it, there we go, it's going to show me an error. Or maybe I want to work with y prediction, play it, and there we go, we have 1 as the value. Now, there is no X predict, so we can also try it. It will obviously show me this error because there is no X prediction value because X is a specific independent variable which could change anytime. So you can work with X or Y anytime you want to. You can also change this value over here like Y over here and X over here, play it, and there we go. You might face this error over here. So just make sure to put the X value first on fitting training data. You can also try X and you might see something like this. Okay, so try an X and Y most of the time and play it out. There we go. We have a different value. And obviously you'll be able to change it anytime you want to. And obviously you will get out the answer you want. It could be 1, it could be 0, or it could be a higher negative value. So thank you for watching this video up till the very end and hope you understood about everything in this class. If you have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. Just make sure to do one thing is that after checking out these videos, just make sure to try it and practice it on your own, because if you do not try it on your own, you will not be able to understand what you want to do and what end result you want to get. So thank you again, and without any further ado, let's move on to our next class. Well, we have done a bit of practical classes. Now we're also going to go back to a couple of concepts which we need to have clear and vivid idea about. So in this class, we are going to learn about statistics and also the probability concepts for machine learning. I have done a bit of research and I am going to present you a presentation which will actually help you a lot. And I'm also going to be giving these lectures or these researches onto my resource folder from where you can get those ideas before getting into more advanced of Python for machine learning. And on most of our classes, we are only going to be using Jupyter for Python and for machine learning. So let's get into this class. So first thing which we need to know is about the descriptive statistics. So there's like mean, median, mode, variance, standard deviation, percentile, and quartiles. Well, if you have worked with Excel, well, you already know about these factors, okay? So what is mean? So the average of a set of numbers. So I've shown you how you can get the actual mean value of a scatter point in a line of regression in my previous classes. So if you still didn't check out those videos, I would suggest you go check out those videos. It will give you a better idea about how you can actually apply it on Python for machine learning. Then we have is median. This is the middle value when the numbers are actually sorted. So while actually getting a specific value from, let's say, maybe a scatter point in this case, or according to this course, you obviously want middle value sometimes. So to find out the middle value instead of mean values on Python, you can also put in median to actually get out the middle value. Then we have is mode, which is the most frequently occurring value. So let's say in a specific time of the year or maybe in a specific region, this is frequently happening, and you could say that it is the mode of that specific value. Then we have is variance. So the average of the square difference from the mean is actually called the variance. So first off, you're going to find out the average of the set of numbers, such as things or maybe even searches or maybe even facilities being used in a certain amount as the average number. But when you actually square up that number, you actually get out the mean value, or let's say the square root of the mean value, but it is basically called variance. Then we have is standard deviation. The square root of the variance indicating how spread out the numbers are. So first off, you obviously need the mean and also then the variance, and then you find out the square root of the variance, which could be lower or higher, plus or minus the mean value. So that is basically called the standard deviation. Then we have is percentiles and quartiles, which values below which a percent or certain percent of observations fall. So these values can obviously like differ from time to time according to the mean value and according to, let's say, a formula or the formula of, let's say, line of regression, like independent value is obviously going to change. So the percentile and the quartiles will change according to the value which you put. Now let's talk about the probability distribution. So there are also four types of probability distribution, but sometimes when you go more diverse into, let's say, AI or machine learning, there's going to be a lot more, and there's also going to be a lot of classifications. So first off, let's start off with the normal distribution. So this is a bell-shaped curve where many natural phenomena follows this distribution. So when you basically work with graphs or maybe chart or numbers, so you might basically see a curve on the line of regression. So when you basically see a bell-shaped curve, it is basically called the normal distribution of data. So it's kind of like, let's say, a convoy, or how actually data move along in a certain phase, but it is a bell shape. So you can already think about that it is a natural phenomena, and obviously all data will not be accessible or, let's say, used in all times. So it could not be in a straight line, but obviously it is just growing consistently. Then we have is binomial distribution. It describes the number of successes in a fixed number of binary yes or no trials, or maybe true or false trials. Then we have is Poisson distribution, which basically describes the number of events occurring within a fixed interval of time or space. So let's say 4 o'clock this morning or 4 o'clock this evening, a specific number of people has accessed this specific data or this specific site. So that is basically called the Poisson distribution. And then we have is the exponential distribution, which basically describes the time between an event and also in a Poisson session. So it could be in a specific time, but let's say from 12 to another 12, or let's say 12 o'clock morning to 12 o'clock at night, this amount of people has accessed this data. So that is basically called exponential data. And now let's talk about inferential statistics. So first off, let's talk about hypothesis testing. So procedures to test if a hypothesis about a data generation process is true. If the value is false, it does not meet up the perfect criteria for a hypothesis testing. Then we have is null hypothesis, or which is also known as HO in short. A default assumption that there is no effect or no difference of a data or maybe even an axis. So alternative hypotheses are, let's say, H1, which is the contrary to the null hypothesis, indicating some effect or some differences in a specific data. Now, sometimes a couple of data is being scaled up and down, but sometimes it doesn't meet up the criteria because obviously all of the data is automated. It doesn't mean that it is not convenient, but there are some effects or there are some differences which you will find out. Then we have is p-value, which is the probability of obtaining test results at least at extreme as the observed data, assuming the null hypothesis is true. So the p-value and hypothesis testing sometimes complement each other. Then we have is confidence intervals, which is a range of values that is likely to contain a population parameter with a certain level of confidence. Now, the last thing which we need to know is about the regression analysis. So first off, we're going to be talking about the linear regression, which I've already showed you in a practical class. So modeling the relationship between a dependent variable and one or more independent variables using a linear equation is called the linear regression. While logistic regression, where the modeling the probability of a binary outcome based on one or more predictor values. So obviously the data is going to change, but it's not going to be the same. But obviously sometimes the data is going to be, let's say, changed or let's say scaled up. So now let's talk about the probability. So first off comes up the basic constant, where we have is a random variable. So obviously the data can change from time to time. So a variable whose values are outcomes of a random phenomenon is called a random variable. Well, let's learn about what the probability mass function or PMF is called, or what is it actually. It gives out the probability that a discrete random variable is exactly equal to specific a value. So obviously we also learned about the calculation of R, which is very important to know about the line of regression, scattered data, and also how you can find out the mean, mode, median, variables, percentile, all of those. So you have to think about this about PMF. Obviously, it's going to match up to a certain data when it doesn't meet up the criteria or where the value is actually equal. Then we have is probability density function, which is also known as PDF, which describes the likelihood of a continuous random variable to take on a given value. So you can change out these independent values anytime manually or even automatically. But obviously we know when it comes to 0, the value is not okay. So you have to keep that thing in mind. Okay. So now let's check out the next one where we have a CDF or cumulative distribution function. It gives out the probability that a random variable is less than or equal to a certain value. So these are the things which you actually have to think about. And PDF or probability density function describes the likelihood of a continuous random variable to take on a given value. So that specific variable is very important because couple of data is also going to be equal to a certain definition or a certain value where the data criteria does not meet up. So to actually make it perfect or to make it convenient, you have to use the other data or other variable numbers, which actually makes up a perfect variable or perfect outcome. Joint, marginal, and conditional probability. Let's learn what joint probability is in a summary. The probability of two events happening together is called a joint probability. So there could be different probabilities at certain times and basic concepts like these two. And we can also talk about different probabilities and aggression or let's say regression. So these probabilities or these stances can obviously cause at certain times. And this is basically called the joint probability. Then we have is marginal probability, where the probability of an event irrespective to the outcome of another variable. So obviously, just like I said, some instances or some cases might complement each other, even though if the definition is totally different and even though if there are different cases. So you have to keep these things in mind. And then we have is conditional probability. The probability of an event given by or than another event has occurred. So the probability of another event happening to actually meet up the criteria when it's obviously not working or not convenient, there is obviously another chance of another event happening. And this is basically called the conditional probability of any specific data. Now let's learn a bit about what the Bayes theorem says. So it basically describes the probability of an event based on prior knowledge to conditions that might be related to the event. And we also have that specific formula. And we're obviously not going to get more diverse right now. We're going to uncover them step by step into classes, which is obviously going to help you to actually keep it more simple and beginner friendly. Then we have is independence and dependence. So independent events. So what are these? So two events are independent if the occurrence of one does not affect the probability of the other. So let's say just in case your own variable or your own data does not meet up the criteria to actually make a perfect fit. So you can use two events to actually get out the probability to be totally perfect and to be a perfect fit. Then we have is dependent events. Two events are dependent if the occurred of one affects the probability of the other. So sometimes what happens is that when you work up with two independent values, sometimes it gives you off, let's say, a perfect fit. Sometimes it does not. But sometimes what happens is that even if you get a perfect fit on the first try, the next instance or the next event also gives you out the best value. So this is like both fit. So what happens is that sometimes in some instances or in some cases or events, one has to depend on the other one, or else the criteria would not actually meet up. Now let's talk about the applications in machine learning. Data reprocessing. Descriptive statistics are used to summarize and understand data distribution. Model evaluation. Statistical tests and confidence intervals help evaluate model performance. Probability or probabilistic models. Techniques like Bayesian networks and hidden Markov models rely on probability theories. Featured selection. Statistical tests are used to identify significant features. Uncertainty estimation. Probabilistic models and Bayesian models provide a measure of uncertainty in predictions. And these predictions obviously occur in these events. So you have to keep those things in mind. And obviously, before getting into more practical classes and more adverse knowledge or more, let's say, steps of going into Python for machine learning without understanding these are going to be, let's say, very tough for you to actually overcome what you actually need. So understanding these concepts is crucial for building and also evaluating machine learning models effectively. So thank you for watching this video up till the very end and hope you understood about everything in this class. Like if you find anything confusing or maybe you have any question, then feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of Python for machine learning. In our previous class, we have learned about statistics and probability concepts. In my previous class, I tried giving you out the best information and also to clear out a lot of things before getting into more practical classes of Python for machine learning. Class, I'm going to clear you out the concept of category of data for machine learning. Now, obviously, there are a lot of type of data which you'll be able to work with. But if you don't have the idea, obviously you will not be able to apply it. So in this class, we're also going to have a presentation or also going to have a series of presentation, which is actually going to give you out the vivid and clear idea about how you can use them and why are they used. In machine learning, data can be categorized based on various criteria, such as the type of data, the structure of the data, and the nature of the learning problem. Here's an overview of the main categories. Based on data type. Based on data type, there are a lot of data, such as numerical, categorical, text data, time series data. So let's start off with the first one. Numerical data. Continuous data. Data that can take any value within a range. An example, height, weight, temperature. These values are not constant. These values keep on changing. So these are called continuous data, and obviously these will change whenever there is any change or when any scalable changes are seen. Discrete data. Data that can take specific values, often integer values, and which is also countable. An example, number of students in a class. So these are basically numerical data, and none of these values are often constant. Categorical data. Nominal data. Data with categories that have no natural order. An example, colors, gender, types of animals. So these categories or nominal data will not change. These are basically constant. Obviously, the data, or let's say the data which actually varies in these types, change, but the nominal data does not. Ordinal data. Data with categories that have a natural order, but no fixed intervals between categories. An example, rankings and grades. So obviously, when ordinal data is used, it does not actually identify nominal data style, but it has the category, but there is no fixed interval between them. Text data. Data in the form of words, sentences, or documents. An example, articles, reviews, and social media posts, etc. Time series data. Data collected or recorded at specific time intervals. An example, stock prices and weather demand. These are the type of data which change more often than the other ones. Spatial data. Data that includes geographical or locational information. An example, maps, satellite images. Some of these data also change, but not most of them. An example, the name of the map can be changed, which can also be termed as a nominal data. But when the structure is changed, it is a whole different thing. So this is basically termed as spatial data. Satellite images also do not change that often because they actually take the exact photo. Image data. Data in the form of images or pictures. An example, photographs, medical scans. These cannot be changed. Audio data. Data in the form of sound recordings. An example, speech, music. Video data. Data in the form of moving images. An example, videos, animations, GIFs, and even more. Now let's talk about data which are based on the data structure. First off, structured data. Data that is organized in a tabular format with rows and columns. An example, spreadsheets, databases. You can also use Excel files. Those are also structured data. Now, what are unstructured data? Data that does not have a predefined structure. An example, like a text document, images, and also audio files. These does not have any structured data inside of it. Semi-structured like structured data. Data that does not have a fixed schema but has some organization properties. An example, JSON, XML, or maybe even CSV. But CSV is termed as the best format of like keeping databases. So this is basically called semi-structured database. Based on learning problems. Supervised learning data. Let's talk about labeled data. Data that include both input features and also corresponding target labels. An example, emails labeled as spam or not as spam. And this is also the feature directly given from the software or from the cloud service. It's because you don't have to term it as a spam, but obviously you have the feature of turning it into a spam or not term it as a spam. But the software, or let's say the service of maybe Gmail, Yahoo, or whatever email services there are, they're going to automatically term if it is a spam or if it is not. Unsupervised learning data. Unlabeled data. Data that includes input features but no corresponding target labels. An example, customer purchase data without any specific label. So, let's say you bought something online or you bought something from a shop and that data does not include input features. You only bought it, you can keep it. So that is basically an example of unsupervised learning data. Semi-supervised learning data. It is a mix of labeled and also unlabeled data. An example, a small amount of labeled data and a large amount of unlabeled data. Reinforcement learning data. Environment data. Data that represents the environment in which an agent operates and receives feedback through rewards or penalties. An example, game environments, robotic control. So obviously when you do robotic control, the robot tends to learn a bit more. And it also has shown you in case or a better example of AI. Some AIs are unsupervised, but they can learn on their own. In game environments, you play the game to get a specific reward, or maybe finish the game, and that is basically called a game reward. Based on source. Primary data. Data collected directly from the source for a specific purpose. An example, survey responses, experimental data. So it could be also done in instances. So most of the instances which you actually use to actually test out. and that is basically called the primary data or data collected directly from the source for a specific purpose. So these surveys or experimental data is basically called the primary data. Secondary data, data that has been collected previously for another purpose, but can be reused. An example, data sets from public repositories, historical data, geographical data, etc. Now let's talk about data based on application domain. Healthcare data. Data related to patient records, medical images, genomics, and etc. Financial data. Data related to financial transactions, stock prices, economic indicators, and etc. E-commerce data. Data related to online transactions, customer behavior, product information, and etc. Social media data. Data from social media platforms including posts, comments, likes, share, and also etc. Sensor data. Data collected from sensors including IoT devices, wearables, environmental sensors, and also etc. Understanding these categories helps in choosing the right data pre-processing techniques, feature engineering methods, and machine learning algorithms suitable for specific types of data and also problem at hand. So hope you understood everything about these data types and why are they actually used for, and how many types of data are available for you to use for pre-processing. So thank you for watching this video up till the very end and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of Python for machine learning. In our previous classes, we've talked about statistics and probability concepts, and also we have categorized the data or learned about the categories of data for machine learning. Now, if you watched my previous lesson properly, there are a couple of things more we and uncover. So I have done a bit of research and I will try to give you out the best explanation of what a qualitative data and quantitative data in machine learning is. So without any further ado, let's move on to our class. In machine learning, data is often classified into two broad categories: qualitative, which is categorical data, and quantitative, which is a numerical data. Each type requires different handling and reprocessing techniques to be effectively used in machine learning models. Here's a detailed look at both. First off is qualitative data, which is categorical. The definition of a qualitative data is that it represents categories or groups and is not numerical. It describes qualities or categories. Now let's check out the types. Nominal data, which is the category with no intrinsic ordering. The examples of qualitative data or nominal data is colors like red, blue, green, types of animals, cat, dog, bird, or gender, male or female. Ordinal data, categories with a meaningful order but no fixed interval between categories. The examples are rantings such as poor, fair, good, excellent, and we also have educational level such as high school, bachelor's, master's, PhD, and also more. The representation of qualitative data is one-hot encoding. It converts each category into a binary vector. So when you are using a binary vector, it's obviously going to be in numbers, even in cases of male, female, and more, such as different categories. Useful for nominal data is an example which I have over here. For color such as red, blue, green, red is basically identified or used with 1, 0, 0. So basically when you put up these values on specific Python cases, you can actually get out the value of red or even sometimes text are elements turning red. If you want blue, you can put 0, 1, 0. For green, it is 0, 0, 1. So you can use these codes or commands to actually change out different characteristics of different elements. Label encoding assigns each category a unique integer, useful for ordinal data. The example of label encoding is for educational levels, such as high school is equal to 0, bachelor's equal to 1, master's equal to 2. So one thing you can see is that each and every one of these pre-processing methods is obviously structured in such a way so that it can complement each other. So you can see school is 0. In the same way, when you are using colors, red is also identified by 1, 0, 0. So one thing you can see is that all of these data can be or is inverted into binary vector. The challenges of qualitative data is handling high cardinality, many unique categories ensuring meaningful representations in models, such as ordinal data, requires preserving orders. So about preserving orders is that it needs an algorithm to work properly. So obviously all of these preprocessions have specific data and specific algorithm to function properly. So one of the most important thing in qualitative data is because of its characteristics, because it needs more analysis on specific commands or specific events. So for qualitative data, it needs a preserving order to actually function properly. Now let's talk about or learn about quantitative or numerical data. The definition of quantitative data is that it represents numerical values and can be measured. It describes quantities or amounts. Let's check out the types. Continuous data, which can take any value within a specific range. It could be 1 from 100, 1 from 1,000, or 1 to million, or maybe even infinity. But most of the time, there is no infinity. There is a specific range. Even in Excel, you can see that even if you go at the top, or let's say maybe if you go to the utmost down, it is or there is a specific range. The examples are height, weight, and also temperature. So what it means is that it also follows up specific laws of height, weight, temperature. So this follows up that specific measurement laws. Discrete data. It can take specific values, often integers, but most of the time it does not work with integers. Okay, so you have to keep that thing in mind. Examples. Numbers of students, number of cars. This is just an example. So the representation of quantitative data is directly used as features in models. Normalization. Scaling data to a range, typically 0, 1. Standardization. Transforming data to have a mean of 0 as the average and a standard deviation of 1. If you checked out my practical classes, then you already know about how these actually work or what these values actually represent. But one thing you can see over here is that all of the values are inverted binary. Challenges of quantitative data. Handling outliers, which is extremely high or low values. Dealing with missing values is also a challenge of quantitative data. Now let's check out the applications in machine learning. Supervised learning and unsupervised learning. We have learned about these a lot of times, but let's check out the classification and also regressions. It often uses categorical data as labels, example, spam or not spam. Regression uses numerical data for both features and also target variables. An example, predicting house prices or even predicting stock prices and etc. Unsupervised learning. Clustering. Groups similar data points based on features, both categorical and also numerical. So unsupervised learning uses both, but supervised learning often uses categorical data. Dimensity or dimensionality reduction. It reduces the number of features while preserving essential information, in example, PCA. Now, you guys might think, what is PCA? Basically, PCA, or Principal Component Analysis, is a dimensionality reduction and a machine learning method used to simplify a large data set into smaller sets while still maintaining significant patterns and also significant trends. And this is very vital to actually categorize data in specific parts, even though if it's not like totally professional. Pre-processing techniques. Qualitative data. Encoding methods are used, such as one-hot or label encoding. It also deals with missing values, such as mode, imputation, creating a new category. Quantitative data uses normalization and also standardization. It also deals with missing values such as mean, median imputation, and also interpolation. Now let's check out the example workflow. Data collection. Gather both qualitative and also quantitative data. Data cleaning. Handle missing values and remove duplicates. Feature engineering. Encode categorical data, scale numerical data. Model selection. Choose models that handle both data types, in example, decision tree, neural networks, and etc. Model training. Train the model using processed data. Evaluation. Evaluate model performance using appropriate metrics. Understanding and properly handling both qualitative and quantitative data are fundamental for building effective machine learning models. Because if you do not know, or if you do not know the concept, idea vividly and clearly, you will not be able to implement the perfect model or what model can actually fix out your problem. So understand these data very properly, do your research on your own, and try it out when you face any problem. In this class, we're going to learn about information gain and entropy and confusion matrix. In our previous classes, we have covered everything you need to know about the statistics, probability, categories of data, and also qualitative and also quantitative. Well, if you didn't understand my previous classes properly, I would suggest you go check that out. And if you have any confusion or any question, feel free to ask me anytime. Because in this class, this is going to be a very diverse, but yet I try to summarize each and every one of them so that it is going to be very helpful for you to understand it before getting into the models of information gain, entropy, and also confusion matrix. So let's get into our class. First off, we're going to learn about information gain and entropy. So what is the definition of entropy? A measure of the impurity or randomness in a data set. In the context of machine learning, entropy is used to quantify the uncertainty or disorder within a set of data. So if we actually need to come to, let's say, a conclusion, it is basically used to evaluate the quality of a model and its ability to make accurate prediction by removing the uncertainty disorder of the set of data. It actually relates macroscopic or microscopic aspect of nature and determines the behavior of macroscopic system in real matter or maybe equilibrium. So it just provides basically a mathematical way to encode the intuitive notion of which processes are impossible. So in a measure of number of ways, a system can be arranged, often taken to be measure of disorder. Now you might think, what is the benefit of using entropy? While it can be used as a function to measure the randomness, it also can be you can also make pre-processing data so that you can remove the uncertainty of the system. And it is basically used while there's a set of data or maybe a range of data sets with scatter points. You'll be able to understand it better when you actually get into practical classes. So to understand various concepts such as feature selection, building decision trees, fitting classification models. So you'll be able to classify them, categorize them, and also remove uncertainty disorder just by using entropy. Now, let's learn about what information gain is and why is it actually used. So first off, let's get into the definition. Information gain is a measure of the reduction in entropy or uncertainty achieved by partitioning the dataset based on a particular attribute. It is used in decision tree algorithms to select the attribute that best splits up the data. In simpler terms, information gain helps us understand how a particular feature contributes to make accurate predictions on a decision tree. So prediction is very important in these cases, which features with higher information gain are considered more informative and preferred for splitting the dataset as they lead to nodes with more homogeneous classes. So basically what it means that it actually leads up to machine learning directly to the AI or even just machine learning to actually learn more and also predict better. To determine which feature should be used to split the data at each internal node or internal node of the decision tree of machine learning. Now, one question is most of the time asked that if it is better than entropy. Well, information gain, which is also stated in bits, indicates the reduction of uncertainty, which is also done by entropy. But in information gain attained by splitting based on a feature, if there are too many characteristics of the tree is too deep, entropy might result in overfitting, while information gain does not. So why do people prefer information gain over accuracy, which is also very frequently asked? Information gain multiplies accuracy with weight of the population to ensure that not just purity, but also sizable chunks are getting split. So if we come to the conclusion, the main purpose of information gain is the amount of audio signal increased by an amplifier when it is expressed in decibels such as dBs, which is basically an example. It is the ratio between input or the output. So it adjusts the tone or the outcome before it gets processed. So now you basically know why information gain is a bit better than accuracy and also, let's say, entropy. Another thing which we need to know is that if it is important for features. So let's say advantage of information gain is effective for feature selection. IG, or information gain, is particularly useful in decision tree algorithm for selecting the most informative features. Not all of them, but the most informative features which can improve model accuracy and also reduce the overfitting of databases. Now, let's learn a bit about confusion matrix, or why is it important. Let's check out the definition. A confusion matrix is a table used to evaluate the performance of a classification algorithm, which is already done by information gain. It compares the actual target values with those predicted by the model and provides insight into the types of errors being made. In my practical classes, you have seen a couple of times there are errors, but sometimes rerunning them actually helps us. So if we just summarize the whole thing, a confusion matrix represents the prediction summary in a matrix form, such as line of regression or scattered data, or maybe even a database form. It shows how many predictions are correct and incorrect per class or per classification. It helps in understanding the classes that are being confused by model as other class. So they can be calculated in a number of other model performance matrix or metrics such as precision and also recall amongst the other. Now there are other services such as entropy or maybe accuracy or maybe information gain. But why is it better than accuracy too? So basically the confusion matrix can provide valuable insights into these crucial distinctions which entropy and also, let's say, accuracy cannot provide, because accuracy will not provide such intuition on the correctly and incorrectly classified points. So if you want a more organized and more managed data and to find it out on its own, then I would suggest you that you should learn a bit more about confusion matrix and about the services and also the models it provides. So there is also another name for confusion matrix. It is basically known as error matrix, which is mainly used for statistical classification. So one thing you have to keep in mind is you have to know about statistical classification, because if you do not know about statistical classification, well, I would suggest you go check out those videos which I've already put. Well, you have to know more about or have the idea, because it can be used properly, or these models can be used properly to actually give out the best result. So just in case, or as an example, as it is used in statistical classification, it is a specific table layout that allows visualizations of the performance of the algorithm. Each row of the matrix represents an instance in a predicted value, while the column represents the actual value, or vice versa. Now, there are four classes of confusion matrix, which I'm going to show step by step. So let's get into the structure of confusion matrix. A confusion matrix for binary classification problem typically has these following structures. So one thing you have to learn is about true and positive values, or about the binary classification, such as positive, negative, false negative, true negative, and etc. So let's get into them step by step. So first line we see is the actual predicted, which is positive and negative most of the time. So in positive, sometimes it is true positive, or sometimes in negative, it is false positive. So you have to keep that thing in mind, is that about true positive and false positive, such as when we have true positive or false positive, it's going to be, let's say, 1 0 or 0 1 and 1 0 again and 0 1, or sometimes 0 0 or 1 1. So one thing you can see, or you have seen in my practical classes, is that no matter how you change it, if you change the independent value before the dependent value, obviously the value is going to be changed, because it does not have the specific structure, or it does not follow a specific path. Okay, so you have to keep these things in mind about the binary classification problems and how to solve them step by step. Now let's check out the applications. Entropy and information gain, which is used primarily in decision tree algorithms. In example, ID3, C4.5, and CART, which is used to select the best attribute for splitting the data at each node or neuron. Confusion matrix, which is used to assess the performance of classification models, providing a detailed breakdown of correct and incorrect classification, which helps in understanding the model's strength and weaknesses. These concepts are fundamental in building and also evaluating machine learning models, ensuring they are both effective and also interpretable. In this class, we are going to learn about the types of events and probability of distribution. In my previous concept classes, I have covered everything you need to know about the types of data, statistics and probability, and also qualitative information, or data, entropy, and confusion matrix. All of them can be applied in this class, and also I'm going to show you after this class of how you can actually apply it and also apply those models. So without any further ado, let's move on to our class. I have created a presentation for you guys so that I can clear you out every confusion or everything about the types of events and probability of distribution. Simple events. The definition of a simple event is an event with one single outcome, not multiple, but one single outcome. The example of a simple event is rolling a dice and getting a tree. Compound event. The definition is an event with two or more outcomes at the same time. Sometimes you can see when we are trying to print out any data, even on Jupyter, there are a couple of datas or a couple of results at the same time. So that is basically called a compound even. The example is rolling a die and getting an even number such as 2, 4, or 6, 8, and so on. Independent events. The definition of an independent event is two events are independent if the occurrence of one does not affect the occurrence of the other. The example is flipping a coin and rolling a dice. The outcome of coin flip does not affect the outcome of the dice roll-up. Dependent event. Definition of a dependent event is two events are dependent if the occurrence of one affects the occurrence of the other, such as not getting the exact result. So multiple events and instances are initiated sometimes. Example, drawing two cards from a deck without replacement. The outcome of the first draw affects the probabilities of the second draw. Mutually exclusive events. Definition of mutually exclusive events are two events are mutually exclusive if they cannot occur at the same time. Example is rolling a die and getting a 2 or a 5. You cannot get both 2 and 5 in a single roll. Non-mutually exclusive events. The definition is two events are non-mutually exclusive if they can occur at the same time. So it doesn't matter if there are 2 or 3, it will still not be termed as an independent or a dependent, neither a mutually exclusive event. It will be termed as non-mutually exclusive event because both of them occur at the same time but are mutually or non-mutually exclusive. The example is drawing a card that is both a red card and the face card from the deck of a specific card. Types of probability distribution. Discrete probability distribution. Binomial distribution. The definition is that it describes the number of successes in a fixed number of binary yes or no trials. Obviously, in numbers or numerical binary, the parameters of a binomial distribution is number of trials, which is termed as n. So this is basically an independent value which can change from time to time. The probability of success is termed as p. So these are, some units or let's say indications which you have to keep in mind. The example of binomial distribution is flipping a coin 10 times and counting the number of heads or even tails, but it has to be specifically one side. Poisson or Poisson distribution. Definition of Poisson distribution is that it describes the number of events occurring within a fixed interval of time or space. The parameter of Poisson distribution is the average rate of alpha of occurrence. Example, number of emails received per hour is also termed as a Poisson distribution. Continuous probability distribution. Normal distribution, which is known as Gaussian distribution. The definition is that it is a bell-shaped curve that's symmetric about the mean. So I've already talked about it, so almost you know about it. The parameters is mean, which is termed as this, and standard deviation. Example is heights of people and also IQ scores. Exponential distribution. The definition of exponential distribution is that it describes the time between events in a Poisson process. The parameter is the rate parameter. Example, time between arrivals of buses at a bus stop. Uniform distribution, which is also part of continuous probability distribution. The definition is all outcomes are equally likely within a given range. Parameters are lower bound A and upper bound B, or it could also be X and Y, but it is most of the time a static or a constant value, which is termed as A or B. The example is rolling a fair dice. Gamma distribution. Definition is generalizes the exponential distribution often used to model waiting times, such as queues and etc. Parameters is the shape k and scale theta parameters. Example, time until the k event in a Poisson process. Multivariate distribution. Multivariate normal distribution, the definition is generalizes the normal distribution to multiple variables. The parameter is mean vector u and covariance metrics. The example is heights and weights of individuals considered together. Now let's check out the applications in machine learning. Discrete distribution, which is used in classification problems and for modeling count data. An example, number of customer purchases. Well, you are already experienced with this, such as online stores or even physical stores. So basically, discrete distribution are used as fundamental tools in machine learning, particularly when dealing with data that can only take a finite number of distinct values. These distributions describe the likelihood of each possible outcome for a discrete random variable. Now, continuous distribution. Used in regression problem and for modeling real value data, an example stock prices, sensor reading, and also etc. Continuous probability distribution also plays an important role in machine learning, from the distribution of input variables to the models. The distribution of errors made by models and in models themselves when estimating the mapping values between the input and also output. The example could be temperature measurements, weight, height, then also time measurements, and also etc. So why does continuous distribution mean, or what does continuously distributed mean? Which means one in which data can take on any value within a specified range. Multivariate distribution, which is used in multivariate analysis, where relationships between multiple variables are studied. An example, principal component analysis, Gaussian mixture model. So, why is it important in machine learning? The multivariate normal distribution is a generalization of univariate normal distribution to two or more variables, which does not work with single component. It is a distribution for random vectors of correlated variables where each vector element has a univariate normal distribution. Now, some people might ask, what is univariate and multivariate? Because multivariate only works with singular, or let's say multiple, not single. In statistics, a univariate distribution is a probability distribution of only one random variable, such as x. This is in contrast to a multivariate distribution, the probability distribution of a random vector consisting of multiple random variables. So, what is the frequency of it? The frequency distribution, where there are more than two variables in the frequency distribution table, is basically known as the multivariate distribution. So now you know about these distribution and how these actually function. Understanding these events and probability distribution is crucial for building and interpreting machine learning models, especially when dealing with uncertainty and also variability in data. So thank you for watching this video up till the very end and hope you understood about everything in this class. If you have any confusion or any question, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of Python with machine learning. In this class, we're going to learn about how to import datasets in Jupyter. In our previous classes, I've shown you how you can use up the codes and how you can function up Python commands in Jupyter. Jupyter is also a very important thing because if you don't know how to import datasets, you will not be able to analyze the data which you download. So let's advance to our class by opening up Anaconda Navigator on our device. And make sure to follow up every steps which I do, because if you do not, it will be a hassle later on. So let's get into our class. As you can see on my screen, I have opened up Anaconda Navigator. Here I'm going to notebook, and just as an example, I'm also going to be downloading one dataset file which I'll be using in this class, and I've also used it in my previous classes too. So you're going to follow up the same steps which I do, or which you see in this class. You can see on my screen I have this file or Jupyter opened up. Now let's open up another tab and download a dataset. So I'm going to be working with Iris dataset. So I'm going to just search for download Iris dataset. That's it. Now after that, what you're going to do is that you have GitHub over here. Just open up this link. You can also open up other ones, but I would prefer using this one. And this is also the same one which we've used in one of my previous classes. So I'm going to download up the zip file. It will take a bit of time to download it up, and there you go, it has been downloaded. And then what you're going to do is open up the folder where we have it, and you're going to extract it. So I'm going to extract to, let's say I'm going to extract it on my desktop so that I can use it properly. So I'm going to search up for desktop. There we go. I'm going to press on OK, and it has been extracted. Okay. Now, first thing, what we have to do is that go off the Jupyter, and I'm going to click on New and click on Notebook. You can also open up a Python file. It will also be very easy for you to use, but you don't have to worry because the kernel version is still going to be for Python. Okay, make sure Python 3 is selected. Now, over here, what you want to do is just type in pwd. That's it. And you're going to press on Shift and Enter. And this is the directory which you want to open up on your device. And it will also be different according to your own device. So first thing, what you want to do is open up your folder, and you have to go off to your PC, just like this. There we go. And over here, this PC, and then you're going to go off to user. And there we go. It's going to be depending on which one you are using on your own desktop. So it will vary from time to time. Now, what you want to do is that I want to take the extracted file over here on this folder so that I can actually play it. Because still you can see it is still not over here, and it will be Iris dataset, but not this one. It's going to be a whole different one. Okay. So I'm going to refresh it again, and there we go. It is still not here. So if we just minimize this, and there we go, we have this over here. There we go, this folder. I'm going to open it up, and there we go, we have these files. So one thing which you want to do is that you have to take out the CSV file which you're going to be working with, not the JSON file. Okay. So here what you're going to do is just Control-C copy, and you're going to paste it iris.csv. So I'm going to open up the browser again, and here I'm going to refresh it. And I'm going to wait until it refreshes, and you will basically find out iris.csv over here. If it's still not here, what you want to do is that you want to refresh it back again. And then you're going to wait until it actually appears up. There we go, Iris dataset. It's still not over here. There we go. We have iris.csv. Now you can open it up anytime you want, and you'll be able to work with it. But you can see when you open up the Iris CSV, you will basically have your own data set, which you will be working in this class. Okay, so let's just go off the untitled file. I'm going to name it, let's say, import, so that it is easier for you to understand. Okay, now here, what you want to do is that you have to import these files, or when you are working with a CSV file, you have to put in or import as Pandas. So I'm going to import Pandas as PG, and you're going to play it up. It will not show you any error, but you can obviously, check out the whole thing. It will obviously work properly for you. And now the next thing, what you want to do is that you have to create your own self, let's say maybe a string or maybe a variable. And for that, you have to name your data set. Maybe let's say I'm going to put in iris underscore data set. And you don't have to worry about this one because it can change. Maybe even if I work with a different value, it will also work. So I'm just going to keep it iris data set equal And now what you want to do is that you have to read up the file. So for reading, as we are working or importing pandas as PD, so we have to put in pd.read underscore CSV. Let me just zoom in a bit more. Iris dataset equal pd dot read underscore CSV. And now you want to define up this file, which we are going to be working with is iris.csv. So inside you're going to put in double quotation iris.csv. And this is the file which we want to open up. Close off the parentheses, shift and run. And still you're not getting out the results, right? So if you want to actually print it out on Jupyter, what you basically have to do is you have to put in iris underscore dataset. That's all. And now you want to shift enter and run the whole thing. And there we go. We have our data set. You can see, and you will also be able to import up different data sets just the same way. So maybe if I go over here, if I put in download data set, there we go. And I would suggest you go off to GitHubs most of the time because it just allows you to actually use specific data sets. So you can also go off to Kaggle, Maven Analytics. There's like a lot of these data sets which you'll be able to download. So you have to just click on download over here, just like this, Maven Analytics. You're going to wait for a bit, make sure that you have stable internet connection. And when you just press on download, there we go, we have CSV. You're going to click on that and it will just start downloading on its own. And I'm also going to be showing you the same way how you'll be able to import this CSV file into Jupyter again. So this one has also been downloaded. Let's just open it up. And I'm going to do is going to be going back. There we go, hospital patients. I'm going to extract it to my desktop again. Okay, there we go. It has been extracted. And you can minimize it and you can also open it up. First off, what we're going to do is that we're going to minimize it and we're going to find out that specific file, which we are going to be working with. Let's just refresh the whole thing. And there we go. We have another file. Let's just open this up. There we go. We have a lot of these CSV files. So from here, we're going to take one of these CSV files. Maybe I want to work up with patients.csv. So if I just copy this, copy, I'm going to paste it over here. There we go. And you can also rename it anytime. Maybe before that, I'm going to just change this out, patients.csv. Okay. So I'm going to open up my browser again. I'm going to refresh it. I'm going to keep going down and I'll find out patients.csv. You can also open it up anytime and check out these data. You can see file load error. If there's an error, what you want to do is that you have to just refresh the whole thing or maybe undo the rename. Now, after you actually rerun the whole thing, I'm just going to close GitHub. And there we go. We have patients.csv. Now, if I open it up, this is how you will actually see it. Let's just wait for a bit. It's loading. And there we go. We have our database. So we can also import it just the same way. So there we go. We have all of these imported as pandas. So here, if I put in patients equal or patients, maybe patients data. I'm not going to put data set. Patients data equal pd dot read underscore CSV. And here I'm going to, let's say, open up the parentheses, double quotation. I'm going to put in patients.csv, double quotation to close it off, and parentheses. And now I'm going to put in patients underscore data set, or let's say just data. That's it. Play up the whole thing. And there we go. We have actually visualized it over here. So it doesn't matter which variable you want to use. Maybe I want to only put in patients. That's it. If I just put in patients, rerun the whole thing, and you can see this is still not working. Well, what you basically have to do is rerun the whole thing over here. And there we go. It is working properly. So this is basically how you are going to import any data set which you want to download. Just make sure that it is in your directory and make sure that it is not, let's say, an errored file, which you've seen just a while ago. Make sure that it works properly first. Open it up on Jupyter and then import it. It will work properly. Okay. So thank you for watching this video up till the very end and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of Python for machine learning. In this class, I'm going to show you about data analysis. If you didn't check out my previous videos about the concepts, about data structures, data categories, and how events actually take place, I would suggest you go check out those videos properly. And if you still or have any question or confusion, feel free to ask me anytime. I will try to resolve it and get back to you as fast as possible. So let's get into our class by opening up Anaconda Navigator on our device. Now, after you open up Anaconda Navigator, I would suggest you open up Jupyter. Already opened up Jupyter on my device on Google Chrome. Now, first thing, what I want to show you is that about how you can get those data sets. In my previous class, I've shown you how you can use any data set which you download, or maybe even if you have your own data set file, you'll be able to use it. Well, in this class, I'm going to be using a Titanic data set, which I'm going to download. So I already downloaded on my device, but how will you be able to get it? So you're going to search in for download Titanic data set. Now, after that, you're going to go off the GitHub, which is a very reliable source. I would suggest you it is very easy to download from there. So basically from here, you will find this option of view raw. Okay, so just keep on going down. You'll be able to download it anytime. You can also, GitHub, open it up. And you have this option over here, download raw file. You're going to download up this like Titanic data set. And then you're going to just, extract it. And then what you're going to do is that you're just going to copy it or, paste it inside of your directory. If you still don't know how to know your directory, what you're going to do is that if you didn't check out my previous video properly, you're going to search in for pwd and run it on this console. And this is basically your directory. So whatever file you put inside of this directory, everything will be available for Jupyter to actually, just paste it or visualize it inside of Jupyter, this console or home console. Okay, so there we go. We have this Titanic CSV, which I'm going to be using. I already have it on my device. So let's just go off and open up another, let's say, another file. So I'm going to click on new and I'm going to click on notebook. And there we go. We have another notebook and I'm going to name it, let's say, Titanic data set. There we go. This is what we're going to be working with. So first thing, as we already know that whenever you want to work with CSV, you have to import it as Pandas. But in this class, I'm going to be showing you how you will be able to use other models too to get out the best and brief about that specific data set. So this is going to be a long video, so I would suggest you make sure not to skip any part, and every command line is going to be very important. So let's start off by importing our file as pandas as pd. And then I'm going to import our NumPy file because I'm also going to be importing NumPy as np because we are also going to be showing you graphical visualizations. Then I'm going to import up, let's say, Seaborn as SNS. Then I'm going to import Matplotlib to actually show you line of regression. Let's say matplotlib.pyplot. There we go, pyplot as plt. Then I'm going to import math. And last one, I'm going to put in percentage. Let's say matplotlib inline. There we go. We have done that. And now the last thing what I want to do is that I want to create my variable. So I'm going to put in Titanic Titanic. It doesn't matter what you put. I'm just going to put in Titanic equal, let's say, pd dot read, then put in underscore CSV, and inside you're going to put in let's say double quotation, Titanic dot CSV, because that is our file, double quotation, close, and there we go. So there we go. We have imported our files, but now we need to actually show the specific data. So for that, I'm going to put in Titanic equal PD read. As that is done, I'm going to put in, let's say, Titanic dot head. You can put in dot head if you want to, because I want to show 10 numbers. So I can put that. And there we go. We have tens of the first Titanic head. Okay. So there we go. We have 10 data from that specific data set, which is actually going to help you to actually, just visualize which data you want. If you maybe want like 20 of these data sets, you can also find 20. If you want to maybe put in 30, you can also do that. And you can also put in 100 if you want to. So there we go. But obviously all of them will not be shown because there's a lot of values. So I'm going to just, in case, I'm going to work with 10 of these values. Now, you want to get out how many people were actually on that specific data set, or how many people has that data. So to do that, I'm going to put another line of code. So here I'm going to print out, open up the parentheses, I'm going to double quotation, and I'm going to create a string inside, hash of, let's say, passengers in original data. Okay, colon, quotation to close it off, hash print of passengers in original data. Make sure to put that. And then here what you want to do is that you have to add it up with a string, str, and then you're going to put in the length function, len, and then inside you're going to put in the CSV file. So I'm going to put in, or let's say the variable, which I'm going to be showing as Titanic dot index. And you're going to close it, all of these parentheses off, shift enter. And if it shows you something like this, that means there is still no data found. But I'm going to print out the whole thing again. Print. There we go. There we go. We have all of these values that are already done. So just rerun the whole thing. And there we go. We have passengers in original data is 891. Now, the next thing, what I want to do is I want a visualization as a count plot. So to do that, what I'm going to do is that put in SNS, okay? SNS dot count plot. There we go, count plot. Open up the parentheses, and I want a variable, which is independent. So equal to, let's say, I want to find out how many people actually survived. So I'm going to put in survived. There we go. Close off the quotation, put in a colon, and you're going to put in data equal to Titanic. There we go. Close off the parentheses. That's it. I'm going to play it up. And sometimes you might see another error like this will appear up. So here, what you want to do is that here I'm going to put in equal instead of that. Data equal Titanic data. Play out. And there we go. Access label has been, it's just showing you how the variables or how many counts was there. Survived was this amount. Okay. So it's also going to show you in Matplotlib sometimes, but I would suggest you do it like this, and it's going to be survived and also the count value. Okay. Now you can also find out like different values. Maybe I can also search up for the sex, maybe how many males survived and how many females survived. So to do that, I'm going to put in SNS dot count plot. There we go. Open up the parentheses, X equal to, let's say, survived. Make sure to actually put in the exact name and exact way it has been put up, because this is also case sensitive. Double quote, like, put in the quotation to close it off, comma, and then you're going to put in the hue equal to sex. quotation, and then you're going to put in comma, and then the data is going to be equal to Titanic. Close off the parentheses and play it up, and there we go. The amount of male survived, or you can see male is this, and you can see, there we go, count is this, and the survival rate is this. Okay, so there we go, higher percentage of female survivors and lower percentage of male survivors, even though the males were higher in percentage. Now let's get out the class. Okay, so you can see there we also have a class. You can see P class. We can also find out that specific value in Matplotlib. So here I'm going to put in SNS dot count again, count plot. Here I'm going to open up the same thing, x equal to survived. There we go. Close off the quotation, comma. The hue is going to be same. Hue equal, this is going to be P class. Make sure it is capital. If it is like, small lettered or lowercase over here, you also have to put in lowercase. There we go. Quotation, comma, and then you're going to put in data equal Titanic. There we go. Close off the parentheses, and there we go. We have the label totally done. And now, what if you want to actually find out the age? You can also do that. So for that, I'm going to put in Titanic underscore data. Now here you're going to put it up as secondary brackets. Inside, you're going to put in age. Secondary bracket closed. I'm going to put in dot plot dot hist. Okay. Open and close the parentheses, play up the whole thing, and there we go. You can see there is another error over here. So I'm going to check out, let's say instead of Titanic data, I'm going to put in just Titanic. There we go. We have our frequency over here applied. So this is basically how you'll be able to actually find out different values. Maybe if you want to find out the fare, you can also find out the fare. So if I put in fare over here, this is the fare or the amount which was taken. So this is how you'll be able to change out and find out and visualize specific data sets. So what if you want to also apply more things, maybe like the pin or the fixed size, you can also change it. So after plot history, what you're going to do is open up the parentheses and you're going to put in pin equal, let's say maybe 20, comma, and then you're going to put in figure size, fixed size, is going to be equal, open up parentheses, 10, comma, 5. Close up the parentheses 2 times and play it out. And it will take a bit of time, and you can see sometimes there is going to be another error. So here we're going to play out the whole thing again. And there we go. You might see an error, but if you just keep on going down and you will basically find out the structure, which actually, shows you out the bin size and also the figure size, which you want to change or which you already changed. Okay. So the next thing, what I want to get from this specific data set is about the data info. So if I want the info, so I can put in maybe Titanic, and they're going to put in Titanic.info, open and close the parentheses, play it, and there we go. We have the class Pandas, and you can see passenger ID 891 non-null, international 64, name, class, and all of these, okay? And you can also see the D types and also the memory usage of that specific data set. Now, what if you want to get the SIBSP? So what I want to do is on the next one, I'm going to put in SNS dot count plot. Here I'm going to open up the parentheses, x equal quotation. Here I'm going to put in SIB SP and then quotation over here, comma, data equal Titanic. There we go. Close the parentheses, play it up, and there we go. We have the count, and we also have the SIBSP. So these accesses are going to give you out the specific data. Now, what if you want to find out the null value, which is going to be the false value, which are, or let's say maybe most of the people who had like not survived. So first thing, what you want to do is put in Titanic dot is null. That's it. Open and close the parentheses, play it up, and there we go. We have these values, which are passengers that did not survive, and we don't have the passenger IDs of them as well. Okay, so the null values are going to be also, very easy to find out when you actually use these code lines. The next thing is that if you want to sum up these null values, what you have to do is Titanic dot is null, and you can open and close up the parentheses dot sum. There we go. Enter, and there we go. We can sum up the values, and you can find out. You can see age 177 in total, and you can see the cabin usage was 687, and also embarked was 2, and the D type was international 64 or INT 64. Now, the next thing, what I want to show you is that how you can find out the C map or maybe the heat map. So the heat map can vary from time to time. So first thing what I want to do is that go on to another cell, and here I'm going to put in SNS dot heat map. There we go. Open up the variable Titanic. Then you're going to put in dot is null. Open and close the parentheses, comma, and then you're going to put in the Y-stick label. Y-stick labels equal to false value. There we go, false value, comma, and then you're going to put in the C map. Okay? Equal, you're going to be using varieties, quotation, VIRIDIS. That's okay. Close off the parentheses, play it up, and you will basically see these are this type of visualization or this type of stocks, because first off you will find out these type of errors might appear up, but this is what you should actually face, or this is what you should basically see, and then you will be able to change out commands whenever you want to. So maybe I want to find out the plot. So if I want to find out the specific plot, what I basically have to do is put in SNS dot boxplot RPLT. That's it. Box PLT. I'm going to zoom in just a bit more so that it is easy for you to see. Open up the parentheses, X equal to the P class, quotation P class, and put in a comma, and Y is going to be equal to the H. Double quotation, and then the data is obviously going to be Titanic. There we go. Close off the parentheses, play it up. If it shows you off an error like this, what you can also do is that you can work with Seaborn directly. So I'm going to create a Seaborn or import Seaborn here. Import Seaborn. And here I'm going to implement it as SNS. There we go. I'm going to create another line. Import Pandas as PD. And I'm going to create a variable. Let's say assuming Titanic, or let's say just Titanic, is the data frame. Let's say I'm going to keep it capital, just for it to understand better. Data frame containing the Titanic dataset. There we go. I'm going to change it to plot. There we go. So we have these datas. So now if I play it out, you can see this is how it should look like, but you're going to just, rerun the whole thing. I'm going to just play out. And there we go. We have our plots and also our C map that is totally working. So this is basically how you'll be able to visualize it when you basically face an error. Sometimes when it shows you an error of, let's say, maybe C-bar not found, so these modules sometimes cannot detect up the data from where you want to import it from. So basically what you want to do is that you have to import it back again so that you can actually visualize it anytime you want to. Okay. So now you understood about how you'll be able to change up these data sets. Now, what I want to do is that after this one, I'm going to show you out the head. If you want to find out the head, or let's say maybe I want the head 5 members, I've already shown you, so I'm just going to put in Titanic dot head and open up, let's say maybe 5 of these values. So there we go. We have 5 of these values and you'll be able to change them out anytime you want to. So let's say maybe I want to find out the cabin accesses. So here I'm going to put in Titanic. Then I'm going to put in a Titanic drop, open up the parentheses, and inside I want the values of the cabin. So if I put in cabin over here, cabin, close off the quotation, comma, access equal to 1. There we go. We have 1, comma, and they're going to put in place to maybe like true or false value, whichever you prefer, equal true. That's it. Close off the parentheses, play it out, and obviously it will detect out that if it is working or not. Now, if we just try to find out that specific, people or these specific people who actually used which number of cabin. Now, if I just put in maybe Titanic dot head, put in 5. So there we go. We have those specific values and we'll be able to use them out anytime we want to. Okay. You'll also be able to implement specific values. Maybe this one like this, or of this one. There we go. Ticket, arch, class over here. Okay. And you can see we have embarked C over here on this specific person. And you can also find out the data of the drop NA. So if I place that as true, or maybe if I put that as false, if I just put in false value, and you can see if I play it out, there we go. It will show me off an error like this. Okay. So the data class or the cabin was not found in the access. So obviously I'm going to change it back to true. I have to put in true. And then on this one, if I play it, there we go. We have those values. Okay. Cabin over here. Now, let me just find out the drop NA. So I'm going to put in Titanic dot drop NA, and I'm going to in place it. There we go. In place equal to true. Close off the parentheses, and there we go. It is also detected. So if it is in place, now I can use the SNS heat map. So here I'm going to put in SNS dot heat map, open up the parentheses. Inside the parentheses, I'm going to put in Titanic dot is null, open and close off the parentheses, and now you'll be working with Y6 labels and also the C bar. So I'm going to put in a comma after this, and I'm going to put in Y6 labels, and you're going to put in equal to false value, comma, C bar, which you want to find out is also going to be the false value. Now you're going to close out the parentheses one time. There we go. And now you're going to run out the whole thing. After playing up that or running up that command, this is how you should actually face the data. So this is basically how you'll be able to find out data analysis, or you'll be able to analyze different types of data just by using these commands. So make sure not to skip any part. And after this is done, make sure to practice on your own. If you still have any confusion or any question about any part of this lesson or any previous classes, feel free to ask me anytime. I'm always there to help you out. Just make sure to practice and not skip any part, because when you skip any part, you might miss out on something very important. And also the command lines are very sensitive. So make sure to follow up. And without any further ado, let's move on to our next class of Python for machine learning. In my previous class, I've shown you how you use Jupyter for data analysis and also use your own dataset. In this class, I'm going to be using the same files, but in this class, I'm going to show you how you can train and also test out data. So there are going to be a couple of things which I'm going to be using, such as accuracy, calculation, and also how I can predict and also train up my data. So make sure not to skip any part because every part of it is going to be very vital to understand about the prediction and how you can train up your model. So without any further ado, let's move on to our class by opening up Jupyter on our device. As you can see on my screen, I'm going to be using which is the Titanic dataset. In this class, I'm going to be showing you how you can train your data. So when you want to train your data, you have to work up with the specific formula, but you have to work with specific axes, such as X value and the Y value. So in this class, I'm going to be doing that. So let's say I'm going to term X and also Y. So X is going to be, let's say I'm going to take it to X over here. Let's just zoom in a bit more. X is going to be equal to Titanic. And then I'm going to drop this value. Titanic drop. And I want to find out, let's say the survived people. So I'm going to put in survived over here, double like quotation, comma, and the axis is going to be equal to 1. And then on Y, I'm going to say Titanic. And then what I want to do is that I want to only find out the people who survived. Okay, so there we go. Close off the second bracket and you're going to just play it. And obviously there will be nothing, or you will basically see no values because we're just training our data. Now I'm going to import specific data from Scikit-learn cross-validation. So I'm going to put in from Scikit-learn dot cross underscore validation. What I want to do is that I want to import up my train test. So after validation, I'm going to import, let's say, train test split. Okay, you're also going to play it. Now you can see this is just another code of line. Now here, the next thing what you want to do is train out your data. So you can train your X data, Y test, split, and etc. and a random state. Now you'll be able to import specific data if you just press on tab. Let's say maybe I'm going to press on tab over here, and you will basically find out a lot of these datas over here. But if you just go off to T, I'm going to go off to T over here. Let's say TR train test data, you'll be able to train them whenever you want to. So I'm going to cut this off over here, and I'm going to put in train underscore test data again. That's it. And then you're going to replay. Now, if I just play it back again, it will still show me this error. So if you basically face this error, this means that the module is not available on your device. So another thing what you can do is that I'm going to just change it from Scikit-learn.model selection and import from train test split. Now, if I play it, it will not show me any specific error. Now, what I want to do is test out specific axes such as X. I'm going to train it, X train, comma, then I'm going to put in X test underscore test, comma, and I'm going to put in Y underscore train. I'm going to cut off one of these over here, one of this over here, Y train, comma, Y underscore test, comma, or after that, you can just train them directly. So I'm going to put in train underscore test underscore split. So there we go, train test split. Now, after the train test split, I'm going to just identify x, comma, y, comma, and then the text size, test underscore size, which is going to be equal to, let's say, maybe 0.3, 0.2, whichever one you prefer, comma, and the random state, which I'm going to be working with, is going to be equal to 1. That's it. Now you want to play out the whole thing, okay? But make sure to keep this just the way it is, okay? So basically, when you play it back again, this is how it will show on your screen, that even though if you see an error, the name is not defined, but it will give you out what you should be doing, okay? So the code is commonly used in machine learning to prepare the data for model training and evaluation. So there we go. We have, let's say, the command totally working properly because this is analyzed. Now, the next thing what I want to do is from Scikit-learn dot linear model. This is also an alternate method. So linear model, which I already used, linear model, I'm going to import, let's say, logistic regression. So now I'm just going to just play it. There we go. Now I'm going to log the model. So log equal, or maybe log model, whichever you prefer, because this is kind of like a variable. So I'm going to put in logistic regression, open and close the parentheses, and that's all. And you might face this error sometimes, but you don't have to worry about it. So you just have to check it sometimes. Regression over here. Play it. There we go. There we go. Now we want to fit in our data. So if I just put in log model dot fit, now I'm going to train up my data, x underscore train, comma, and if I just put in y underscore train, okay, close off the parentheses and play it out from Scikit-learn dot metrics, import classification report. There we go. I'm going to play it out. And now what you want to do is that you want to feed more data, such as classification underscore report. And then what you want to do is that you want to test out y underscore test, comma, and then you want to put in predictions. Okay, that's it. Then you want to replay the whole thing. There we go. And now on the next one, what you want to do is that you can also put in some accuracy to your models. So if you want to put like confusion matrix, so you have to put in from Scikit-learn dot metrics. I'm going to import confusion matrix. Play it. And then you can do is apply the confusion matrix. Confusion underscore matrix. And then it could be different values. You can see function Scikit-learn classification labels none, sample weight none. But obviously there is like no data right now, but if you have your own data, it will obviously give you out these results. Then obviously we learned about positivity, negativity, and the Boolean values. It will give you out in those values. So you also have to learn a bit about the, let's say, formulas and how those actually work and which data is actually going to give you out the perfect fit. So thank you for watching this video up till the very end and hope you understood about everything in this class. If you still have any confusion or any question about any part of this lesson, feel free to ask me anytime. I'm always there to help you out. So without any further ado, let's move on to our next class of Python for machine learning. In my previous class, I've shown you how you can data analyze. And in this class, I'm going to be showing you about logistic regression curve. In my previous classes in this course, I have covered up a lot of lectures and a lot of concepts, which actually gives you out the idea about how to operate Python for machine learning. And we also had a couple of practical classes. We're going to implement each and every one of the things which we learned in these type of classes of ideas and also these lectures. So in this class, we're going to learn about logistic regression curve, and I have done a bit of research on it. So let's get into our class and make sure not to skip anything. Logistic regression is a statistical method used for binary classification, which means it predicts outcomes in one of two possible categories. Unlike linear regression, which predicts continuous outcomes, logistic regression outputs a probability that a given input point belongs to a particular category. So let's check out the key concepts of logistic regression. Function. The core of logistic regression, sigmoid function. The core of logistic regression is the sigmoid function, also known as the logical function or logistic function. It maps any real valued number into a value between 0 and 1, making it suitable for probability estimation. Probability and decision boundary. The output of the sigmoid function is a probability. By setting a threshold, commonly 0.1, the model assigns the input to one of the two categories. If the probability is greater than or equal to the threshold, the input is classified into one category. Otherwise, it is classified into the other. Cost function. Logistic regression uses a cost function derived from the livelihood of the observed data. Training. The model parameter beta are typically estimated using maximum likelihood estimation, or known as MLE. Now people might think, what is MLE? MLE, or maximum likelihood estimation, is a statistical method used to estimate the parameters of a probabilistic model based on observed data. The goal of MLE is to find the set of parameter values that maximize the likelihood function, which measures the probability of observing the given data under the assumed model. So what MLE works, or how does MLE learn or work with machine learning? An example, it could be logistic regression. So MLE is also a part, or MLE is used in logical or logistic regression, often solved using gradient descent or other optimization algorithms. Now let's learn about logistic regression curve. The logistic regression curve is the graph of the sigmoid function applied to the linear combination of input features. This curve shows the relationship between the probability of the outcome and the input feature S. Shape. The logistic curve is an S-shaped sigmoid or sigmoidal curve. Interpretation. The steep part of the curve around the midpoint indicates the range where the model is most sensitive to change in the input features. The flatter parts at the end indicates ranges where the model's predictions are more certain. So this is a visualization about the probability and about its curve. So you can see over here, we have this line over here, and there are certain parts of y-axis and also its x-axis. In a multi-dimensional space, logistic regression still outputs probabilities, but the decision boundary between the two classes can be more complex. An example, a hyperplane in higher dimensions. Applications. Logistic regression is widely used in various fields such as medical diagnosis, marketing, finance, and even binary classification problems. So let's get into them step by step. Medical diagnosis. Predicting whether a patient has a particular disease. An example, diabetes, cancer, heart attack, or heart issues, sugar issues, and all of those. So these type of logistical lines are used to actually, let's say, categorize and also predict whether a patient has a particular disease. Marketing, determining whether a customer will purchase a product or not. Now, determining is something also a bit of prediction and also a bit of marketing. It's because it depends on the algorithm and also what it is getting, or what the software or even the service is getting the data and also learning from the behavior of the user. Finance, assessing the likelihood of loan default. Binary classification problem, any scenario where the outcome can be categorized into two distinct classes, true or false, which is one of the most basic classification, and also the trials. In case of binary, the outcome must be a categorical or discrete value. It can be either yes or no, or 0 or 1, true or false, etc. But instead of giving the exact value as 0 and 1, it gives the probabilistic values which lies between 0 and also 1. Sometimes there's also like minus values, which you'll also be able to use. Now, there are three types of logistic regression: binary, multi-nominal, and also ordinal. They differ in execution and also theory, while binary regression deals with two possible values, yes or no. So now we basically know everything, or we know the basic concept of logistic regression. So what is the ROC curve in logistic regression? ROC curves are graphs that plot a model's false positive rate against its true positive rate across a range of classification threshold, that is, across various cutoffs, used to split real-valued model outputs such as probabilities into binary prediction, yes or no, true or false, 0 or 1. In our previous class, we've learned about AWS DevOps service, and we also covered up most of the services provided by AWS. So in this class, we are going to learn about the decision tree of AWS algorithm. So let's check out the overview of what a decision tree is. A decision tree is a popular machine learning algorithm used for both classification and regression tasks. It represents decisions and their possible consequences, including outcomes, resource cost, and the utility. Let's check out the structure of the resource, or let's say the decision tree. Root node. It represents the entire data set, which is then split into two or more homogeneous sets. Internal nodes. It represents the features, attributes of the dataset, and the decision criteria applied to these features. Leaf nodes represent the final output or decision corresponding to the target value. Splitting. The decision tree splits the data at each node based on a certain criterion to make the most homogeneous subsets, which is called pure nodes. Common splitting criteria include Gini impurity, entropy, and variance reduction. So let's start off with Gini impurity. Gini impurity measures the frequency of a randomly chosen element being incorrectly classified. Entropy, which is also known as information gain. It measures the amount of uncertainty or impurity in a specific dataset. Variance reduction. It is used for regression tasks to minimize the variance within subsets. There are types of decision trees. classification tree, and regression tree. Classification trees are used when the target variable is categorical, and regression trees are used when the target variable is continuous. So let's check out the advantage of decision tree. Easy to understand and interpret. The tree structure is easy to visualize and understand. No need for feature scaling, such as decision trees do not require normalization or standardization of feature. Handles both numerical and categorical data. Can be used for diverse types of data. The disadvantage of using decision tree are overfitting, unstable, and bias. In overfitting, decision tree can easily overfit the training data, leading to poor generalization on unseen data. Unstable. Small variation in the data can result in a completely different tree being generated. Bias. Trees can be biased on the dominant class in the dataset. So pruning. To counteract overfitting, pruning methods are used, such as pre-pruning and post-pruning. Pre-pruning means halts the tree growth early by setting conditions like maximum depth, minimum sample per leaf, or minimum information gain. Post-pruning, which allows the tree to grow fully and then removes the least significant branches based on certain criteria. So whichever data is inconvenient, it is being removed or is removed automatically. Ensemble methods. Decision trees are also fundamental components in more complex ensemble methods like random forest and gradient boosting machines. Random forest. It combines multiple decision trees to improve robustness and accuracy. Gradient boosting machines, or GBMs. It builds trees sequentially to correct the error of the previous trees. Application. Medical diagnosis. To decide on a diagnosis based on patient data, credit scoring to evaluate the risk of lending to a borrower, and marketing to segment customers based on their behavior. Decision trees are versatile and widely used due to their simplicity and interpretability, making them a valuable tool in various machine learning applications. So, if we have to summarize it and explain it simply, a decision tree is a tree-like structure that represents a series of decisions and their possible consequences. It is used in machine learning for classification and regression tasks. And there are four types of decision trees. So there could be ID tree, which is interactive dichotomizer tree, C4 CART or CART, which is classification and regression tree, CHAID, which is chi-square automatic interaction detection, and MARS, which is multivariate adaptive regression splines. So where are decision trees used? Decision trees are commonly used in operation research and operations management. If, in practice, decisions have to be taken online with no recall under incomplete knowledge. So, a decision tree should be paralleled by probability model as the best choice model or online selected model algorithm. And you can also create yourself up a decision tree by defining your main idea or question, by identifying your root node, by adding potential decisions and outcomes, then expand your tree by adding potential decisions, expand until you hit endpoints, calculate the risk and reward, and then evaluate the outcome. And you can also read out the decision tree by starting from the root node. and then go to the next node, and the edges will tell you which subsets you are looking at. Once you reach the leaf node, the node tells you the predicted specific outcome. So, and you can also use, let's say, the formula of EV equal first possible outcome into likelihood of outcome plus second possible outcome into likelihood of outcome and minus the cost value. Welcome to a new class project 2. The name of the class project is K-means clustering algorithm. I have attached in a description and also an outcome. The K-means clustering algorithm is an unsupervised machine learning algorithm used to partition a dataset into K clusters, where each data point belongs to the cluster with the nearest mean. Let's get into the steps. Install required libraries. Import necessary libraries. Create a sample dataset. Apply K-means clustering. And step 5 is visualize the cluster. I'm going to show you all the codes and code line to actually help you to visualize your data so you don't have to worry about it. Just make sure not to skip any part. The outcome of running the K-means clustering code is visual representation of the clusters formed by the K-means algorithm. The dataset points are colored according to the cluster they belong to, and the cluster centroids are marked with a different symbol. In this case, red XS. So let's get into our class by opening up Jupyter or any IDE which you have on your device. So as you can see, I have opened up Jupyter. So I'm going to create another notebook just like I did on my first class project. And here I'm going to name it class project 2. There we go. We have it renamed. And what you're going to do is that if you still don't have, let's say, pip install, or if you didn't install the kernel yet, but I already have it installed, so you don't have to worry about it. You can see pip installed. So here, what I'm going to start doing is I'm going to import up my libraries. So import NumPy as NP. And then I'm going to say from Scikit-learn.cluster. I'm going to say import K-means. I'm going to import Matplotlib because we are going to visualize our data. Matplotlib.pyplot as PLT from Scikit-learn.datasets import make blobs. And one thing what we want to do is that on this one, I'm going to, let's say, just concatenate all of these data all together, but make sure not to make any mistake on these command lines. You can also do it individually from cell to cell, but I'm just going to try to do all of them at once. Now here I'm going to create a class, generate sample data. Okay. So X, which we have over here as the independent value, underscore equal to, let's say, make underscore blobs. And we're going to use a different, let's say, maybe a predicted value, N underscore samples, which is going to be 300. Okay. Equals to 300, comma, centers is going to be equal to 3, so 3 values, comma, cluster standard, which we have, is going to be, let's say, 0.60, comma, and we also need a random state, which is going to be equal to 0. This is just a random state, so you don't have to worry about it that much. There we go. And now what I'm going to do is that let's just create more of these. Let's say I'm going to create another class. In this class, I'm going to initialize the k-means. Initialize k-means with 3 clusters. There we go. So k-means, which we have, is equal to k-means, open up the parentheses, n underscore cluster is going to be equal to 3. Now I'm going to create another class to fit the model of the data. So hash fit the model of the data. So k-means dot fit x. Now here, hash gets the cluster centroids. So I'm going to use the centroids equal to k-means dot cluster center underscore at the end. Now what I'm going to do is that I'm going to label each data. So for that, I'm going to create another class. Let's say I'm going to, let's say, get the cluster labels for each data. Or let's say for the data points, which we are going to use. So I'm going to say label equal to k-means dot labels underscore hash plot the clusters, and I'm going to say plt dot scatter, open up the parentheses, say x is going to open up the second bracket, after that colon comma 0, because we don't want any specific value, comma, let's say like close off the second bracket, comma, now x again, open up the second bracket just the same way, comma, and this one it's going to be 1 because we are clustering up the data, not the accuracy. So the C label, C equal labels, comma, S equal 50. Okay, you can use different values, but that's like totally perfect. 50 is like an average value, and I'm going to use CMAP such as varieties. So I'm going to open up only single quotation, varieties, close off the parentheses at the end, and now you want to visualize your data. But before that, you have to label these specific data too. First off, I'm going to create another class, which is going to plot the centroids. There we go, plot the centroids. So plt dot scatter, because we need scatter values inside of our visualization. Scatter centroids. There we go. Open up the second bracket, colon, comma 0, because it's the same thing which we've done. Second bracket close, comma, centroids. Open up the second bracket again, colon, comma, 1, second bracket close, comma, s equal 200. Let's just remove this. 200. C is going to be equal to, let's say, red value, or it's going to be in red or maybe in orange, whichever we prefer, comma, marker equal to x. Second bracket again, or singular bracket, whichever one you prefer. So let's just do single quotation on each of them. There we go. X, close off the parentheses. Now the title, plt title, you can use whichever you prefer, but as I've already used that class, let's say I'm going to put in like K means cluster, means clustering, close off the parentheses, PLT. Now we're going to label our X and Y. X label. So I want X label to feature maybe 1. So I'm going to say feature 1, close off the parentheses, PLT dot Y label, feature 2. There we go. Now I'm going to show all of that, PLT dot show. Okay, so this is all of the command lines which you have to follow up. Okay, and now you want to play all of these. So right after that, just play it. And there you go. We have the X values and also the K clustering means. So basically, this is how you'll be able to use K clustering algorithm to cluster up the data and also visualize it in scatter points, or maybe even called centroids. Okay, so this is how you'll be able to use it. Now, even if I put like feature Z over here and feature Y over here and play out the whole thing, it's going to be feature Z and also feature Y. So another thing what you can do over here is that if I put in 20 and play out the whole thing, it's going to be smaller. Okay, so size is 20. If I change it, if I want to increase it to 100, it's going to be a lot bigger. Over here, if I change the centroids to maybe, let's say 300 and play it, it's going to be a lot bigger. And instead of red, I can also put in purple. There we go. We have purple X's too. So this is how you'll be able to actually mention or change any of these data. I can also put Y, and you can see there we go. We have this error because you can see Y, it is not visible. So I would suggest you just use X most of the time, but it's not that it's just not going to visualize it, but obviously it's going to give you how the K means clustering data inside of your visualization or whatever you want to visualize inside of these graphs or scatter plots. So thank you for watching this video up till the very end, and hope you understood about everything. After you're done, just make sure to take a screenshot of it. So thank you again, and hope to see you guys in my next course.